is ethical hacking course. But in reality, it's just an expansive video on the fundamentals of ethical hacking. There is no such thing as an ethical hacking course, to be honest, because no course can teach you a discipline like ethical hacking. All the best that you can do in creating content for ethical hacking is that you can tell people about the fundamentals that are followed in this discipline. Okay, now before we start, let me just give you a general idea of the topics that I intend to cover throughout this video. Okay, now to be honest, we're going to cover a pretty broad range of material. We are firstly going to be going over footprinting and reconnaissance, where you get an idea of what's involved in the ethical hacking engagement that you're working on and information about the target that you're engaged with. Then we're going to talk about networking fundamentals, and here we're going to get our hands dirty with packets and the understanding of TCP/IP at a deeper level, and also understanding how the different protocols work and why they work that way. Now, we are also going to be talking about cryptography, where we talk about different cryptographic ciphers. We're going to deal with web encryption to SSL and TLS. We are also going to talk about certificates and the creation of certificates and how they actually operate. We will also talk about public key cryptography, and we are also scanning and enumeration, so Nmap, and dealing with Windows servers and using SNMP and LDAP and all that sort of stuff. Then we're going to be talking about penetration, where we deal with different ways of getting into systems and also go over using Metasploit, which is an exploit framework. And we're going to talk about how to use Metasploit, and you actually get into systems and make use of the exploits that they have. Then we're going to talk about malwares, viruses, and worms and rootkits, and all of that sort of stuff. We're going to take a look at the different pieces of malware and how you would pull that apart in order to understand what it's doing and potentially make use of that malware during an ethical hacking engagement. Then we're going to talk about different types of denial of service attacks or DOS attacks and the difference between a denial of service attack and a distributed denial of service attack. And there is a difference there. So we're going to go over those attacks. Now, we're also going to go over web application hacking and the types of tools that you would use during web application hacking and the different vulnerabilities that web applications have and how to make use of these exploits and those vulnerabilities. We're going to talk about wireless networking, how to probe wireless networks, what wireless networks are doing, and how to secure wireless networks. We're also going to talk a little bit about detection evasion. And to be honest with you, detection evasion kind of comes up in a lot of different areas through the many of the topics that we're also going to talk about programming, programming attacks, and how to protect oneself against programming attacks. Okay, so that was the number of topics that we're actually going to cover through this video. Now, the approach that I'm going to be taking in the series of videos is whenever possible, we're going to be going to use a hands-on approach. So we're going to show you the actual tools I'm going to make use of and the tools to do some sort of demonstration and how they actually work. I am a big believer in getting your hands dirty as the best way to learn anything. So as we go through the series of videos, I strongly encourage you to get access to the tools that I'm going to be demonstrating wherever possible and dig in and get your hands dirty along with me. And there are places where we're going to be going over some theoretical material, and I'm not a big fan of PowerPoint slides. But sometimes they're a necessary evil in order to convey certain types of information. So wherever possible, I'm going to minimize their use, but you will run across places where they're just a necessity. And we're going to have to go through some slides where in order to get some particular points across, they are primarily of a theoretical nature. So that's the approach that we'll be taking through this video, and I hope you have fun as you go along the way. Okay, so let's begin. Now, the first topic that we're going to tackle is what is hacking? Okay, so let us take a trip to the early days of hacking to start with. Now, the Internet Engineering Task Force is responsible for maintaining documentation about protocols and various specifications and processes and procedures regarding anything on the Internet. They have a series of documents called the Request for Comments or the RFCs. And according to RFC 1389, it says a hacker is a person who delights in having an intimate understanding of the internal workings of a system, computers, and computer networks in particular. While the expression hackers may go back a long time and have many different connotations or definitions, as far as computers go, Some of the earliest hackers were members of the Tech Model Railroad Club at the Massachusetts Institute of Technology. And what those people did and the various things that they did and were involved in are detailed in Stephen Levy's book called Hackers for Our Purposes. Now, for our purposes, we'll be talking about other types of hackers. Although the spirit of what we do goes back to those early days, now the definition of hacking or hackers has changed, particularly in the 1980s, and in part as a result of a couple of people, namely Robert T. Morris, who was a Cornell graduate, who unleashed a piece of software that was called a worm on what was an early version of the internet worm, went on to cause a lot of damage and create a lot of downtime on systems across the country and across the world. Now, the Morris worm did end up resulting in something good, however. That is, the Computer Emergency Response Team at Carnegie Mellon was created primarily in response to the Morris worm. Now, there's also Kevin Mitnick, who is another well known hacker who was responsible for various acts of computer crime over a couple of decades. He was the first convicted in 1988. So, the definition of hacker or hacking moved from something benign to something far more sinister in popular culture. Now, we see hacking or hackers in all sorts of popular culture. We've seen them in hacker movies called war games, also the movie Hackers. Of course, you also see it in the Matrix movies, where you can see, if you look really closely, that they are using a tool called Nmap, which we will get into the use of in great detail later on as we go on. Now, also the movie Sneakers and the movie Swordfish. And on television, in addition to other places, you can see the agents at NCIS regularly doing things like cracking complex cryptography in just a matter of seconds or minutes. So, what is hacking really? Well, hacking is about a deep understanding of something, particularly with relation to computers and computing. It's also about exploring and the joy of learning new things and understanding them very clearly and being able to manipulate those things in ways that maybe other people haven't before. It's also about digging into problems to find out solutions in creative and interesting ways, and sometimes finding problems where there weren't problems previously. And that's a little bit about what is hacking. Okay, so now that we have talked about what exactly is hacking and how the meaning and connotations of that word has changed over time, how it came into existence, how it was coined, let's go over the reasons that people normally hack. Now, you may want to hack just for fun. As discussed previously, hacking is a tradition that goes back several decades at MIT, even preceding the computer related definition of hacking. Now, MIT has a long and storied history of hacking, and sometimes of a computer related nature, which in this case happens to be true, and sometimes of a non computer related nature instance. Now, here you can see that MIT's homepage has been hacked, or you might even say defaced, to indicate that Disney is buying MIT. This was an April Fool's Day prank in 1998, and again, this is just the kind of hacking that you would do for fun rather. Now, sometimes you might want to hack just to prove a political point, or any point for that matter. In this case, again, Bill Gates had donated some money to the MIT, which allowed them to have a new building. And he was coming to MIT to visit and give a talk about Microsoft Windows and its systems. And as you can see, the Windows systems that were installed in the entryway at the building were hacked to be running Linux instead. And you can see here that Tux the Penguin is saying, "Welcome to the William H. Gates building." Again, that's some students who decided that they wanted to make a point about Linux and Microsoft and Windows to Bill Gates, and they thought hacking was the best way to go about it. Sometimes you hack just for the challenge. Here's an example again at MIT, where some students turned the facade of a building into a Tetris game board. Now, this was a reasonably difficult hack, and the students went after it just for the challenge of completing it. And it just so they could have some pride of ownership and to be able to say that they were able to pull this off. You know, the things that teenagers do to show off to other teenagers, it just increases with increase in scale. Now, in spite of its difficulties and its challenges and all the obstacles and planning that had to go into it, they were able to pull it off, and now they have those bragging rights. So that was one of them, and one of the instances where somebody would hack just for the challenge and for the fun in it. Now, sometimes you want to hack to prevent theft, and this is where we get more specifically into computer related hackings. You see a lot of articles and stories in the news over the last few years about cybercrime. And here's an example of data theft compromised. And a few than 1.5 million cards for global payments. So there are some attackers who got into this company, Global Payment, and they were able to pull out about 1.5 million credit card numbers during the intrusion there. So what you may want to do is you may want to learn how to hack in order to find these holes in your systems or applications or employer systems so that you can fix these holes and prevent these compromises from happening because of the reputational hit that your company takes whenever things like these happen. You have the risk of completely running out of business. So, just to protect your job, to protect your company, and to protect your own desire of business, you may just want to learn to hack, and that's a very good reason. Now, you may also want to find all the problems that exist in your system before putting them out and deploying them so that you can keep these attackers from getting in and stealing critical or sensitive information. Sometimes you may want to hack to get there before the bad guys. And the same sort of idea is the last one where we're just going to talk about, and that exactly is ethical hacking. Now, we were just talking about how sometimes you may want to hack into your own system before publishing it out to the public. Let's take Internet Explorer for example. Now, Internet Explorer was actually published to the public with some critical error in the code, and these flaws were heavily exploited by people who actually found them. Now, a number of people in the world go out looking for these flaws and they call themselves security researchers and they get in touch with the vendors after they found a flaw or a bug and work with the vendors to get it fixed. What they end up with is a bit of reputation, they get a name for themselves, and that name recognition may end up getting them a job or some speaking engagements or a book deal or any number of ways that you could cash in on some name recognition from finding these sort of bugs and getting them fixed. If you want to get there before the bad guys, you may think you're helping out a vendor, you may want to just make a name for yourself, you may want to find these sort of bugs before the bad guys do because the thing about the bad guys finding them is they don't announce them and they don't get them fixed, and that makes everybody a little less secure. Finally, you may want to protect yourself from hacked computer companies and fight cybercriminals. And this is a new headline from June 18, 2012. And we're starting to see these sort of news headlines show up as companies are starting to retaliate against attackers in order to retaliate against attackers. Now, in order to retaliate against attackers, you need to be able to have the same sort of skills and techniques and knowledge and experience that those attackers have, and where your company may want you to learn to hack, or the company may want to bring in people who are skilled at these sort of activities so that they can attack the attackers, and hopefully you end up with more steely exterior and you get a reputation for not being a company that people want to go after. Those are several reasons, and there we go. I gave you around a bunch of reasons as to why you may want to hack: for fun, to prove a point, protect yourself, to protect the company, to not run out of business, and along with another bunch of reasons. Okay, so now that we have talked about why you would want to hack, let's move on to the types of hackers that exist. Now, we're going to be talking about the different types of hacking, and the first type of hacking that I want to discuss is ethical hacking and ethical hackers, which is really what we're going to be talking about through the rest of these lessons. Now, an ethical hacker is somebody who thinks like a black hat hacker, or thinks like somebody who's intent on breaking into your systems but follows a moral compass that's more in line with probably the majority of the population. So, their intent isn't to do bad things. Their intent is to look for bad things and get them fixed so that bad things don't happen. Ethical hackers aren't out to destroy anything and they're not out to break anything unless it's deemed to be acceptable as a part of the engagement and also necessary in order to demonstrate a particular vulnerability to the organization that they're working with. So that's an ethical hacker, and there's a certification that's available from the EC Council. It's a certified ethical hacker, and if you find certifications valuable and this sort of thing is what you want to do, pursuing a certified ethical hacker may be something you might want to look into. Now, let's talk about black hat hackers. There's plenty of cases of black hat hackers through years, and let's talk about a guy in particular called Kevin Mitnick. This guy right here is a particularly good example, probably because he was a black hat hacker for a lot of his years. His goal was to cause mischief, to steal where necessary, and just to be engaged in the lifestyle of being a hacker and doing whatever was necessary to continue doing whatever he was doing. It crossed moral boundaries or ethical boundaries. And so Kevin Mitnick here was involved for well over a decade in computer crime and was finally picked up by the FBI, and he was charged and prosecuted, and he was eventually convicted of some of the activities that he was involved with. Now, you may be able to argue that Kevin is a grey hat hacker, and a grey hat hacker is somebody who kind of skirts the line between black and white hat hacking. And white hat hacking is really what an ethical hacker is. So instead of saying ethical hacker, you could say white hat hacker. It's the same idea. A white hat hacker is somebody who hacks for good. If you want to think of it like that, if you want to think of it as a good versus evil, and what they're really doing is they're in it for the technical challenge. They're looking to make things better, make things more efficient, improve them in some way. On the other hand, a black hat hacker is out for the money, for the thrill. It's really a criminal activity. And a grey hat hacker is somebody who may employ the tactics and technique of a black hat hacker, but have sort of a white hat focus, in other words. They're going to do things that may be malicious and destructive in nature, but the reason they're doing it is to improve the security posture of an organization that they are working with. So you can see there's actually a book called Grey Hat Hacking. It's a pretty good book and it details a lot of the tactics and strategies and techniques we'll be going over in subsequent lessons in this video. Now, one other type of hacking that I want to talk about is a thing called hacktivism, and you'll find hacktivism all over the place. And one example in the last year or so, and certainly in recent memory, is called Lulz Security. Yeah, you heard that right. It's called Lulz Security. And you can argue that Lulz is actually a response to another type of hacktivism. An organization called Anonymous started hacking companies like Sony to protest their involvement in a lawsuit regarding a PlayStation 3 hacker. Now, Lulz Security was supposedly protesting the treatment of Anonymous or was hacking in support of this group. Anonymous, so they hacked a number of companies and did things like pulled information, usernames, and passwords from the databases at these companies. And they said that the reason was to shine a light on the security of these companies and also theoretically to embarrass the companies with their weak or poor security postures. And the problem with that they were doing this through were posting information that they had found online, and that information often included details about customers for these particular corporations. And for an ethical hacker, a white hat hacker, that would cross the boundary of causing harm. So there's no reason for me as an ethical hacker to post information in a public forum about somebody because I could be doing damage to them. But in this case, Lulz Security and Anonymous, specifically Lulz Security, were engaged in a form of hacktivism, and what they were doing was not only damaging to the corporation, that certainly was detrimental to those people. So different types of hackers and different types of hacking. We've got ethical or white hat hacking, we've got black hat, grey hat, and then we've finally got hacktivism. It's really the goal and the means that vary from one to the other. Okay, so now that we've discussed the types of hackers, let's also discuss the skills necessary to become one. So what we're going to discuss in this part are the different skills that are required or will be learned as a part of this video. So initially, just for basic computing, you need a basic understanding of operating systems and how to work them. There are going to be several fundamental types of tasks that I won't be going into any detail at all, and you'll need to know how to run programs and do things like open up a command prompt without me walking you through and how to do that. So I am going to assume that you have some basic understanding of how to do these sorts of tasks. Also, you need an understanding of the basic system software, and you'll need a basic understanding of how to use command line utilities. There are a number of tools and programs that we're going to be going through this video, and many of them use the command line. Now, whether it's on Windows or Linux, you'll need to be familiar with typing and being able to run programs from the command line and the various command line switches and parameters that those programs or types of programs are going to use. Now, from a networking perspective, you need a basic understanding of some simple networking concepts. You need to know what cables are and switches and hubs and how systems are networked together. You don't really need a deep level of understanding. I'll be going through some protocols at a reasonably deep level because I think it's important as an ethical hacker to understand what's going on at the protocol level so that you can know better what you are doing and how to achieve the goals and tasks that you have before you. So we're going to be going over some protocols. So just understanding what protocols are and how they go together, those sort of things are necessary from a networking perspective. Now, we're going to also be learning a bunch of life skills. Yes, there are some life skills that it's important to have. I think the most important one is the ability to accept failure and persevere. And by that, I mean you're going to be just running across several things that just don't work the first time around. And it's going to take a little bit of time and stick to itiveness to plug away and keep going until you get something to work. And the way that you get things to work is having an ability to problem solve. And sometimes solving problems requires being a little creative. Sometimes you need to think out of the box and come at a problem from a different perspective in order to find a solution. Throughout the course of this video, you're going to run across a lot of sticky problems through the course of learning about being an ethical hacker and just doing the work because it's not as simple. So here's a little recipe for how to do this. Now go follow this recipe every time and you're going to be successful. Every situation is different, every system is different. You're going to run across some pretty sticky problems and you're going to have to just wait and get your hands dirty and keep failing and failing and failing and failing until you find a way to succeed. So I think those skills are very necessary to learn how to be an ethical hacker. Digging through some of the material that we'll be going over in this video, as far as what you're going to be learning, you're going to be learning about how to use a lot of tools. You're going to learn networking, and by that I mean we're going to be talking about different protocols that are involved in networking systems together. You're going to learn about security and security postures. Security is the heart and soul of ethical hacking. It's why we do ethical hacking in order to make systems and networks more secure than they were previously. That's the goal from a networking perspective. We're going to be talking about how to read packets from network captures. We're going to be going into TCP/IP related protocols in a fairly significant amount of detail. And you're going to understand how protocols interact with one another. So we're going to do all that, and the reading packets is going to be really important. And we're going to do a fair amount of that in addition to just a fundamental approach to learning how to read packets in several lessons. We're going to read packets as a way of understanding the different tools that we're using and how they're going to learn tactics and methodologies. And you get to learn to use the information you've gathered in order to get more information. And information is really what is this all about. You can't do much, anything without information. And sometimes it takes a fair bit of digging in order to find that information. And what you're going to learn is the entry points and the stepping stones to get the information that you need. And then once you have that information, you're going to be learning about ways to exploit it in order to get deeper into the target. You're going to learn security awareness. We're going to talk about risk and understanding risks and vulnerabilities. Primarily, recognize the difference between a vulnerability and an exploit, and there's a significant difference. There's so security awareness and understanding what a risk is and how that impacts your target, and it's going to be key to a lot of things that we talked about. So it sounds like a lot. We're going to cover a fair bit of ground, not all of it at a deep level. Sometimes we're going to skim the surface, but there's an awful lot of material to be covered. So let's get started into talking about the different skills that are required or will be learned as a part of the series of video. So initially, just for basic computing, you need a basic understanding of operating systems. So it sounds like a lot that we're going to cover, and a fair bit of it is going to be at a very deep level, and sometimes we're just going to skip the surface. But there's an awful lot of material to cover, so let's get started. Okay, so that was all about the skills that we're going to develop throughout this video, and that might be necessary for you to become an ethical hacker. Now let's talk about the types of attacks that you might be dealing with as ethical hacker yourself. So now we're going to be talking about the types of attacks. Now, one type of attack that you'll find common, particularly in cases of hacktivism, for example, or cases where people are trying to make a particular point or just be a general pain, is this idea of defacing. Now, defacing goes back for quite a while. It's the idea of sort of digital graffiti where you've left your mark or your imprint behind so that everybody knows you were there. Primarily a website thing, and it's really just making alterations to something that used to be pretty common a long time ago. Now, it's very particular for businesses or people or just organizations in general to have their home pages be replaced by this other thing that was along the lines of, hey, I was here and I took over your web page. We also have a pretty common one, or certainly has been common over the years, and it's a pretty good path towards quality exploits and high profile vulnerabilities and that's buffer overflow. Now, a buffer overflow is a result of the way programs are stored in memory. When programs are running, they make use of a chunk of memory called a stack. And it's just like a stack of plates. When you put a bunch of plates down, when you pull a plate off, you're going to pull the top plate. You're not going to pull the oldest plate, you're going to pull the one that was on top. So the same thing with the stack here. We're accessing memory, and this has to do with the way functions are called in memory. When you call a function, a chunk of memory gets thrown on top of the stack, and that's the chunk of memory that gets accessed. And you've got a piece of data in memory within that stack, and that's called a buffer. And when too much data is sent and tried to put into the buffer, it can overflow. Now, the bounds of the configured area for that particular buffer, it can overflow the bounds of the configured area for that particular buffer. Now, the way stacks are put together, we end up with a part of the stack where the return address from the function is stored. So when you overflow the buffer, you have the ability to potentially override that return. At which point you can control the flow of execution of programs, and if you can control the flow of execution of the program, you can insert code into that memory that could be executed. And that's where we get buffer overflow that turns into exploits that creates the ability to get like a command shell or some other useful thing from the system where the buffer overflow is running. So that's a buffer overflow in short. Sometimes we also have format string attacks, and sometimes these can be precursors to buffer overflow formats. Now, format strings come about because the C programming language makes use of these format strings that determines how data is going to be input or output. So you have a string of characters that define whether the subsequent input or output is going to be an integer, or whether it's going to be a character, or whether it's going to be a string or a floating point, that sort of thing. So you have a format string that defines the input or the output. Now, if a programmer leaves off the format string and just gets lazy and provides only the variable that's going to be output, for example, you have the ability to provide that format string. If you provide that format string, what then happens is the program starts picking the next piece of data off the stack and displays them. Because that way we can start looking at data that's on the stack of the running program just by providing a format string. And if I can look at the data, I may be able to find information like a return address or some other useful piece of information. There is also a possibility of being able to inject data into the stack. I may be able to find some information like a return address or some other useful piece of information. There is also a possibility of being able to inject data into the stack. I may be able to find some information like a return address or some other useful piece of information. There is also a possibility of being able to inject data into the stack using this particular type of attack. Now, moving on to our next type of attack is a denial of service. A denial of service, this is a pretty common one, and you'll hear about this a lot. This is not to be confused though with the one that I'll be talking about after this, and that is a distributed denial of service. So this one that you see this is a denial of service attack. And a denial of service is any attack or action that prevents a service from being available to its legitimate or authorized users. So you hear about a ping flood or a SYN flood, that is basically a SYN packet being sent to your machine constantly, or a Smurf attack. And the Smurf attack has to do something with ICMP echo requests and responses using broadcast addresses. That one's been pretty well shut down over the last several years. You can also get a denial of service simply from a malformed packet or a piece of data, where a piece of data is malformed and sent into a program. Now, if the program doesn't handle it correctly, if it crashes, suddenly you're not able to use that program anymore. So therefore, you are denied the service of the program, and thus the denial of service. Now, as I said, a denial of service is not to be confused with a distributed denial of service. And I know it's pretty trendy, particularly in the media, to call it any denial of service a DDoS or any denial of service a DDoS. Now, it's important to note that any denial of service is not a DDoS. A DDoS, or as you might know, a distributed denial of service, is a very specific thing. A distributed denial of service is a coordinated denial of service making use of several hosts in several locations. So, if you think about a botnet as an example, a botnet could be used to trigger a distributed denial of service, where I've got a lot of bots that I'm controlling from a remote location, and I'm using all these bots to do something like sending a lot of data to a particular server. When I've got a lot of systems sending even small amounts of data, all of that data can overwhelm the server that I'm sending it to. So the idea behind a distributed denial of service attack is to overwhelm resources on a particular server in order to cause that server not to be able to respond. Now, the first known DDoS attack used a tool called Stockhold Rot, which is German for barbed wire. Now, Stockhold Rot came out of some work that a guy by the name of Mixter was doing in 1999. He wrote a proof of concept piece of code called TFN, which was the Tribe Flood Network. Let me just show that for you. So you can see on the Wikipedia page that the Triflood Network, or TFN, is a set of computer programs that is used to conduct various DDoS attacks such as ICMP floods, SYN floods, UDP floods, and Smurf attacks. Now, I know many people don't really consider Wikipedia a really good source of any sort of knowledge, but it's a good place to start off. So, if you want to read about all these types of attacks like ICMP floods and what exactly is a SYN flood, you can always do that from Wikipedia. It's not that bad place. Of course, you shouldn't use Wikipedia as your final Rosetta Stone. Moving on. So this program called Old Rod, it was used to attack servers like eBay and Yahoo back in February of 2000. So that attack in February of 2000 was really the first known distributed denial of service attack, which is not to say that there weren't denial of service attacks previously. So to that, there were certainly plenty of them, but they were not distributed. Now, this means there weren't a lot of systems used to coordinate and create a denial of service condition, and therefore we get the distributed denial of service attack. So that's a handful of type of attacks and some pretty common attacks that you're going to see as an ethical hacker when you become an ethical hacker, or if you're trying to become an ethical hacker, you should always know about these types of attacks. Okay, so in this lesson, we're going to be talking about penetration testing and some of the details around how it works and logistics and specifically things like scope. So what exactly is penetration testing? So, well, not surprisingly, it's testing to see if you can penetrate something, which means you're going to check to see whether you can break into a particular thing, whether it's a server or in applications, depending on the type of engagement you've got. You may have the ability to try to break in physically to a location, but primarily what you're going to be doing with penetration testing is you're going to be trying to break into systems and networks and applications, and that's the kind of what it's all about. And this may actually involve social engineering attacks. So it may require you to make a phone call to somebody and get them to give you their username and password, or some other type of social engineering attack, where maybe you send a URL via a crafted email. Sometimes it's just strictly a technical approach where you're running scans and you're running Metasploit and you're gaining access. That way, or maybe some other type of technical application sort of connection. Sometimes it's physical access that you need. So in order to get access to a particular system, if you can get physical access, then maybe you can get in. So that's what exactly penetration testing is. It's checking whether you can get into a system, whether it be physically or on a network. So what are the goals of penetration testing? The goals would be to assess weakness in an organization's security postures. You want to figure out what they're vulnerable so that they can go and fix these problems. You want to help them understand their risk positions better and what they can or may be able to do to mitigate those risks. And ultimately, you want to be able to access systems in a particular way to find weaknesses. So those are really sort of the goals of penetration testing. Now, from a result standpoint, when you're done your testing, what you are going to do, well, you're probably going to generate a report. And by that, I don't mean you're going to run some automated tool and you're going to get it to generate a report for you. You're actually going to give that to the client. You're actually going to give your report to the client. And then they're going to write you a really large check. So that's not really how it works. You're going to write a report detailing the findings in a detailed way so that it includes what did you do to find out what you actually found out and how you can actually mitigate that particular risk. So you should really include remediation activities in order to fix these vulnerabilities that you find. And it's pretty easy to walk around saying, hey, that's a problem and that's a problem and that's a problem. That's really not a lot of value. In that, where there's a value is that, hey, that's a problem and here's how you can go about fixing it. So let's talk about the scope of penetration testing. So firstly, you want to actually realize how big is the breadbox and how specifically what is it that the two of you have agreed, that being you, the ethical hacker, and the other guy being the authorized person to give you permissions to ethically hack, have specifically agreed that you can do penetration testing and you can target them as an organization or the client And what you have agreed to are any exclusions or any sort of areas that they say you're not allowed to touch. So anything, so like if they've got a database server maybe, or there's a lot of really sensitive data on it, and there's a little hesitant, and they may put a don't touch this thing clause in the scope. So there are a lot of different reasons why they may exclude areas from the scope, and if they exclude them, then trust their reason and listen to them. What they have to say in terms of this is what we want you to accomplish. So along those lines, you really need to get a sign off from the target organization. Now, we've talked about this before, and this is certainly all about the ethics and trust, and it's also about legality because if you do something that you don't have permissions to do, you could be prosecuted for that. So, definitely get the scope very clear in writing and with signatures attached to it as to what you can and what you can't do, and always get approval from the right people and make sure you get somebody who has the right level of permissions and is the right level of management so that they can sign off on its understanding and accept the risk that is associated with a penetration test. So let me talk a little bit about security assessments and how they differ from penetration tests. The security assessment is a hand-in-hand approach with clients. So you would walk in doing a collaborative thing where you're a trusted partner and you ally with them, and your goal isn't to penetrate them and point out all the things that are really bad, but it's to get a full assessment of the risk that the organization is exposed to, and you would probably provide more details about fixes that maybe you would in a penetration test. Now, what we're going to do is we're going to walk in and make sure that the policies and procedures they have in place are really what they need for the organization and the risk appetite that they've got. And we're going to make sure that the policies and procedures have controls that can tell us whether they are being actually adhered to or not. So the procedures and policies are being followed. A security assessment is probably a little bit more comprehensive than a penetration test, and you would look at more factors to assess the security postures of the organization in their overall risk. And you would tailor the output based on their risk appetite and what they're most interested in. And that's not to say that I'm going to tell them what they want to hear, but if there's something that they know and I know that they're just not going to do, I'm not going to be making a big deal out of it because they're already aware of it. And I'll make a note of it in the report just for a completeness sake. But I'm not going to go out in a lot of detail, so it's really kind of a hand in hand collaborative approach. Where again, you're not just saying that they want us to say we're providing some real security and risk guidance towards their activities and other things. So it may provide an unrealistic view. So you've got a week, let's say, to do this penetration test against your target. Now you're going to have to go in, you're going to have to get set up, you're also going to have to start doing a bunch of scans and make sure that you're gathering information and screenshots and data for your reports. You're going to have to do all sorts of activities. Also, during the course of that week, you're going to be engaged in probably beginning to write your report and getting a sense of what is going to say and what's going to be in it. If you don't actually get any major penetration during the course of that week, the organization may feel like they're quote unquote secure. That's one of the reasons why penetration testing, while really sexy and show, is nice and all, but if an organization walks out of it believing that in a week you didn't manage to get the keys of the kingdom, then they must be secure. That's really a misguided view because a dedicated, skilled, and motivated attacker isn't going to just take a week or some portion of that week. If they're after something, they're going to dedicate themselves to it and really go after it. So just because you didn't find a penetration in some subset of a week doesn't mean that they're secure and invulnerable to attacks. It just means that during the course of that particular week and other circumstances that were in place, you didn't get a penetration that was really significant or major. That's all it means. It doesn't mean anything beyond that. And if an organization walks away feeling like they're secure, they're going to end up not fixing the real vulnerabilities that may be in place that could expose them to significant risks. So that's penetration testing, its scopes, its goals, and how it differs to security assessments. Now it's time to go over footprinting. So what is footprinting? Well, footprinting is getting an idea of the entire scope of your target. That means not just the scope that you were given, which may be an address block or it may be a domain name, that even may be a set of address blocks. Now, what you want to do is you want to figure out all the information that's associated with that in great detail as you can possibly get. So, you want a list of domain names as you're going to go through this. You probably want some sort of database or Excel spreadsheet or something to keep track of all the information because you're going to have a lot of it at the end. You want to be able to find the information quickly. So having some sort of either notepad going with your notes, or as I said, a spreadsheet or a database. So if you can get organized in that way, you want to keep all those sorts of things down. So in this case, I want to do some sort of search on, suppose, let's say edureka.co. Now I need network blocks. So far we found out that just made up IP addresses because I'm just putting information down. But I need network blocks. So you may have one IP address that you can find externally, or you're going to want a whole range of internal blocks, and you can do a little bit of digging if you aren't provided those. You want specific IP addresses for critical systems, web servers, email servers, databases, if you can find any of these things of those sorts. And you want system architectures. And what kind of stuff are they running? Are they running Intel? Are they running Windows? Are they running some Unix systems? What are they running? What kind of access control list they have? These are going to be hard to get, but you may be able to guess them. And you can guess these by doing port scans. So what sort of responses you get back from the port scans with the filters, and or what you don't get back will tell you about if there's an IDS around, or some you want to do a system enumeration, or you can get access to a system somehow. You want to know usernames, group names, so on. So the basic idea of footprinting is gathering information. Now, if you can get access to systems somehow, you want to know usernames, group names. So you want system banners, routine tables, SNMP information if you can get it, DNS host names if you can get those. So now this is for both internal and external on the side. If you're doing an internal penetration test or ethical hacking engagement, you want to know the networking protocols that are there. Are they using TCP/IP, or are they using some UDP, or are they on IPX or SPX? Are they using DECnet or AppleTalk? Or are they using some sort of split DNS? In other words, do they have internal DNS servers that give different form for their external? And will it give different information if you want to check for remote access possibilities? Now, in the footprinting process, you want to be very exhaustive. You might want to try and take out email addresses, server, domain name services, IP addresses, or even contact numbers. And you want to be very exhaustive with your approach. You don't want to miss anything out. Because if you do that, you can continue and also provide some launching points for additional attacks or tests that you may be able to do. But this is definitely a starting point of the types of information that you need to have as you go about footprinting your target. Now, next thing that we are going to see is very interesting. This is one of the many common tools that are out there on the internet, and that is the Wayback Machine, or also known as archive.org. Now, while it might not give you all the information that you need, but it certainly gives you a starting point. And what we're talking about out here is the Wayback Machine, or archive.org. So let me just give you a quick look at what archive.org looks like. Okay, I already have it open out here. So out here, what you can see is how a website looked like around some time ago. So for example, if you want to look at what Google looked like, so you just have to search for Google out here and wait for results to come back. Okay, so we see that Google goes way back to 1998. So that was the last capture, or the first capture rather. It was the first capture by the Wayback Machine, and we can see that it has a screenshot of November 11th and how Google looked. So let's see what Google looked like in November 11th of 1998. So this is what Google looked like. There was actually nothing to it. It just said, "Welcome to Google, Google search engine prototypes," and it has some link. So yeah, this is what the Google search engine looked like. It had a Stanford search, it had a Linux search, and you could do all sorts of stuff. You could just put the results. Now, what I'm trying to tell y'all is you can see the evolution of a website through time through the Wayback Machine. And this gives you rather informative look into how website has actually evolved. Okay, now that we know what footprinting is and how it falls into the whole reconnaissance process, so let's go over a couple of websites to do a little bit of historical digging about companies and the types of infrastructure that they may be using. And this information, of course, is useful so that we can narrow down our focus in terms of what we want to target against them for attacks. Now, over time, we've improved our awareness about what sorts of information we may want to divulge. So several years ago, you may have gone to a company's website and discovered that you could get email addresses and names of people in positions that you may find relevant. And there were all sorts of bits of information that could be used against the company. And over time, we have discovered that those sorts of pieces of information probably don't belong on a website. where they can be used against a company, and so they've been pulled off. Now, it used to be also that Google had the ability to pull up information that it had cached so far. For example, if a website was no longer available or if it was temporarily down and offline, there was a little cache button that you could click when you did and the Google search, and you could pull up that cached information. So even though the website wasn't available, you could still get information from Google's servers. Now, Google's removed that, so we don't have that ability any longer. However, there is an internet archive that we can use. So this thing is called the Wayback Machine, and I have it open out here. So it's archive.org/web. So archive.org is a website that gives us information about other websites and how they looked like in years ago. And by so, I'm going to go to the Wayback Machine, which you can see is at the archive.org, and I'm going to go and try and search for edureka.co. So now we're going to take a historical look at edureka.co's website, and you can see we've got some years, and they've got information going back up to 2013. So let's look at what this website looked like when it was just 2013. Okay, there doesn't seem to be any snapshots out here. I wonder what's going on. Okay, so let's go to 2014. And the first snapshot seems to be on the September 12th of 2014. Actually, it's on May 17th too. So let's see what that looked like. Okay, so this is what Edureka looked like back in 2013, or rather 2014, September 12th, 2014 to be actually exact. Now you can see that we have some live classes and all these pictures are there, and they've got this weird picture of this guy out here. I don't know why that was a thing back in 2014. Now we can browse more advanced screenshots, or rather the screenshots that were taken later on, and see how this company has evolved with its infrastructure and the way it actually lays out its content. Okay, so it still hasn't evolved, but I can go a couple of years ahead and see what this has actually evolved into. So if I were to go to December 2016, so this is what it looked like in 2016, and we can see that they've added this weird box out here about browsing courses. They have added a search bar that kind of looks weird, but it's mostly because my internet is slow and it's not loading all the elements. They've also changed how they've actually laid out the courses. We can also see a change in the prices, I guess. So yeah, this tells us about how it evolves as a complete website. Now, this other website that I want to talk about is called Netcraft. Now, Netcraft does internet research, including the types of web servers that companies run. And they have a web server surveys. You can see here as we scroll that Apache Web Services has 64.3% of the internet market, of course, and that's followed by Microsoft with 13%. Interesting information, maybe useful information, but even more useful than that is looking at what different companies run for their websites. And you can see here. Okay, so let's try and search for edureka.co out here. So let's just put in the website URL, and let Netcraft generate the site report. So as you can see that some of the stuff is not available. We know that the NetBlock owner is by Amazon Technologies. The name server is this thing right here. The DNS admin is AWS DNS host master. We also have the IP address. We can go for a virus, look up the IP on VirusTotal. We can do that. There is no IPv6 present, so that's some information that we can see. So we can obviously opt out to not target IPv6 ranges. Then there's also reverse DNS. Then we also have a bunch of hosting history. So this is a history of it. And we know that it's hosted on a Linux system with an Apache web server. And it was last seen, and this was when it was last updated. So this is some very useful information. You can also get information on stuff like Netflix. So if you just type, okay, I just spelled that wrong. So let me just change it from the URL out here. So if you go and type for netflix.com, and you'll see that it'll show you all sorts of information. So as you see that it's on an AWS server, it's an Amazon Data Services Ireland, and this is all the hosting history that it goes along with. It has some sender policy frameworks, domain-based message authentication and reporting confirmations. And there's all sorts of information that you can get about websites and their web servers from Netcraft. So the Wayback Machine, along with Netcraft, make up for some interesting tools that are available on the internet, from which you can do a little bit of your reconnaissance process. Okay, now that we have gone over Netcraft and the Wayback Machine, now it's time to actually get to know how to use the little information that this site actually provides. So what the next topic that we're going to go over is using DNS to get more information. Now, we're going to be going over a tool, and this is called Whois, and it is a utility that is used to query the various regional internet registries to store information about domain names and IP addresses. And let me just show it to you about all the internet registries that are there. So I have aaron.net open out here, and these are the internet registries that provides the ISPs and looks over the internet control as a whole. So out here we have Afrinic, we have Apnic, we have Aaron, we have Lacnic, and we have Ripe NCC. So these are all the regions and all the different types of stuff that they support, all the different countries. You can look at the map that it is supporting out here by just hovering over the providers. So as you can see, all these brown region out here is Africa, Afrinic. Then we have Apnic, which is this black or grayish thing, which is India and Australia and quite a lot of Asia. Then we have Aaron, which is a lot of North America and the United States mostly. Then is Lacnic, which is mostly the Latino side, which is the South American part. Then we have the rest of Europe, which is Ripe NCC, and this is the part that Ripe NCC is providing internet to. Okay, so that was all about the internet registries. Now let's get back to the topic, and that is using DNS to get more information. Now for this, we're going to be using a Linux-based system. So I have Ubuntu running on my virtual machine out here, and let me just log into it. So firstly, we are going to be using this query called Whois that looks up these internet registries that I just showed you. Let me just quickly remove this. Okay. So for querying information from the regional internet registries that I just talked about, you can use Whois to get information about who owns a particular IP address. So for example, I could do Whois, and let's see, I could do Whois Google, or rather Netflix.com, and we can get all sorts of information about Netflix. So we can see that we have the visit mark monitor. Then let's see, let's go up and look for all sorts of information that is being given to us by this Whois query. So as you guys can see, I just went a little bit too much. Okay, so registry domain ID. We have the domain ID where it is registered. The registered URL is mark monitor. Okay, so this is for marking actually. Now the creation date is 1997. So if you haven't realized, Netflix been around for a long time and it's been updated on 2015. And the registry expiry date, as we see, is 2019. So it's going to actually go off this year. Then this is all useful information. So we can see all sorts of domain status, the name server, the URL, the DNSSEC that it says unsigned. This is very useful information that is being provided by a very simple query. Now, if you want to know who owns a particular IP address, so let's see. Did we get back the IP address out there? We should have got back the IP address, but it's kind of lost on me. So to get back the IP address also for a domain name service that you know, so you could use this command called dig. So you dig netflix.com. Now, as you guys can see, that it has returned a bunch of multiple IP addresses. These are all the IP addresses that Netflix is. So I could do something like if I was trying to check out who owns a certain IP address, and for example, I have got one of these IP addresses, but let's just assume I don't know that it actually belongs to Netflix. So I can go whois 54.77.108.2, and it'll give me some information. So as you guys can see, it is giving us a bunch of information as to who this is and how it is happening. So we see that it is from aaron.net, and so we can very smartly assume that it's from the North American part. Now, we can also see that it's in Seattle, so our guess was completely right. So it also gives us a range. So this is something very useful. So if you see, we now have the range of the IPs that might be being used by this guy. So we indeed have 54, and it says it goes up to the 54. There's also 34. Now let's check that out and see what information we get. So who is, and let's check it out. What was the IP that we were just seeing? It's 34.249.125.167. So 34.249.165. I don't know. Let's see. You can also put in a random IP address. It doesn't really matter, and it'll give you the information. So let's see. Is this in some IP address? Even this seems to be an Aaron IP address, and it's also based in Seattle. and we get a bunch of information. So that's how you can use the whois query and the dig query to actually get all sorts of information about the domain name service and get information from a DNS basically. So now let's go over some theoretical part that is for DNS. So using DNS to get information. So firstly, what is a domain name service and why do we need it? So a domain name service is a name given to an IP address so that it's easy to remember. Of course, it's easy to remember names and mnemonics rather than a bunch of random weird numbers. Now, this was mainly so that we can map names to IP addresses and we can get a bunch of information from the hostname resolution. So that's the purpose of IP addresses. Now, we will also be looking at how to find network ranges. Okay, now before we get on to actually moving on to how to find out the network ranges, let me just show you how you can also use whois. So whois, suppose you want to know the domains with the word foo in it. So you could go whois foo. And this will give you a whole bunch of things about how foo exists and all the sorts of foos that there is on the internet. So that was one interesting flag. And if you want to know how to use more about whois, you could just go dash dash help, I guess. Yeah, so this is all the types of stuff that we can do with whois. So we can set the host, we can set the port that we want to search for, then we can set with the L flag, we can find one level less specific match, and we can do an exact match, do an inverse lookup for specified attributes. Then we can also set the source, we can set verbose type, and we can choose for a request template. I mean, there's a bunch of stuff they can do. So you could suppose say whois verbose and suppose edureka.co. And it'll give you a verbose version of this is a RIPE database query service. The objects are in RPSL format. The RIPE database is subject to. So, okay, let's try something else like whois netflix.com. Okay, I'm sorry. I was supposed to do verbose and I kept doing H. Silly me. So you do V and it'll give you a much more. Like this is a RIPE database. Again, I think I'm doing something wrong. Okay, just for that thing. Okay, V and type. Okay. Or let's just see. Let me just show you how to use it. Primary keys are returned. Only primary keys. Okay, let's see. Let's try that out. Okay, so it seems to be that this is a RIPE database query service, and the objects are in RPSL format, so it won't really work for that thing. And it also says that no entries found because it's this error. So this is for some later lesson. So for now, I hope I gave you a good idea of how to use whois. Like you could just go whois and some IP address like 192.168.101 or some gateway address like that. Or you could just go for a domain name service like Facebook and get all sorts of information about Facebook when the query actually returns you something. Okay, so let's move on to network ranges now. Now, in this part of the video, we're going to be going over the utility called whois, which is used for getting information from the DNS. Now, let me just show you a website out here. So this is the regional internet registries. So the internet registries are used to store information about domain names and IP addresses, and there are 5 regional internet registries. First is ARIN, which is responsible for North America, so that would be the US and Canada. Then we have LACNIC, which is responsible for Latin America and portions of the Caribbean. Then there's RIPE, that's responsible for Europe and Middle East and Central Asia. There's AFRINIC, which is responsible for Africa. And finally, we have APNIC, which is responsible for Asia Pacific Rim. So that's the regional internet registries. And as I said, whois is responsible for querying information from the various regional internet registries, as you can use whois to get information about who owns a particular IP address. So for example, let me just open up my Ubuntu system. Let me clear this out first. So as I was just saying, for example, you could go whois facebook.com. Okay, so as you guys can see, we could find out pretty quickly about who owns a particular IP address. So for example, I could do whois and just go facebook.com. It tells me about who it belongs to. It also gives you who owns a particular IP address and who's responsible for them. From the information, you can get email addresses that belong to a particular company. This one has an email address for tech contact of ipreg @ so you can get all sorts of email addresses, tech contacts, and all sorts of stuff out there. The registry database contains only .com and .net and all sorts of information. Now, I want to query a different IP address and different information belongs in the different regional internet registries, of course. So if I want to go to a particular database, I would have to use the -h flag. So I could do whois ARIN net and remember the IP address, and I'm going to query that again. And of course, I get the same information back because I went there. So you could just go who is h and then follow it with an IP address. So something like 34.205.176.98. So that's just a random IP address I just made up. And it says that who is option. Okay, so it's a capital H. Okay, so let's see that. And we get all sorts of information back from that. So area 8, Aaron, and all sorts of stuff. Now I can get information about domains as well. So if I can query something like netflix.com and I can find out that this is that actually Netflix and there's an administrative contact and a technical contact, and you can see the different domain servers. So the servers that would have authority of information about the DNS entries for that particular domain. You can also see other information like when the record was created, and a whole bunch of different phone numbers that you can contact. And additional to storing information about IP addresses and domain names, sometimes it will store information about particular host names. And there may be other reasons why you would store a host name or particular information about a host name on a system within one of the RIRS. Now, if I wanted to look up something specifically, once I had found that, I could now do a lookup on who is, suppose, let's say, something like who is foo. So let's say who is foo. Now, if you already don't have who is installed, you can easily install it by just going apt install who is on your Unix system, and that should do the trick. And then you can start use this really nifty tool. Okay, so that was all about using who is. Now let's get on to actually using how to find out network ranges for a domain. Okay, so now let's talk about how we're going to be going over and finding network ranges. So suppose you've got an engagement and you only know the domain name and you don't know much beyond that, and you're expected to figure out where everything is and what everything is. So how do you go about doing that? Well, you use some of the tools that we either have been talking about or will soon be talking about in more detail. And the first thing I'm going to do is I'm going to use the domain name edureka.co, and I'm going to look up edureka.co and see if I get an IP address back. So let's just head over there and go who is edureka.co, or we could use the host keyword. So as you see, we get an IP address back, and that is 34.210.230.35, and that is the IP address. And you see that I've got back an IP address. So here's just an IP address, and I don't know what that IP address belongs to. I also don't know how big the network range or network block is, and that's associated with. So what I'm going to do is who is, and I'm going to look up with Aaron who owns that IP address. So you can basically go who is 34.210.230.35. So as you guys can see, that gives us a bunch of information and who is. Now, this doesn't seem to have a very big network range, but unlike something like Netflix, so suppose we were to do something like host netflix.com and see. Now we have a bunch of IP addresses. So suppose we were to do who is, let's see, who is 52.19.40.147. Now I'm expecting Netflix to be a much larger company and have a better, yeah, now see, we get net range. So this is the network range that we're talking about. So we had a random IP address and now we have found the network range. So that's how you find network ranges, and this can be very useful. So this gives me evidence that Netflix.com has a presence on different addresses. The one I have also located by looking up that particular host name. So I've got one address here that I can look at, and let's take a look at the website because that may be a different address. Now, if I didn't have that, I could also go and do something like an MX flag. So let's see. I could go dig, and this will give us all the mails. So dig MX, and let's see what MX does actually. You go help. So we could do dig-h for a list of options. So these are all the options that we have, and the one that we're going to use is something like this. So dig mx, and we say something like netflix.com. So these are all the mailings and MXs that we have gotten from Netflix, and this is information regarding it's still producing information. That's a big thing to produce. Okay, so as I was just saying, you can use the MX flag, and I could get back all the mail handlers in this case, and their mail is being handled by Google. And let's see, wait, let's go on top. Then It's going to tell me that Google's not particularly surprising, and other things that you can do is check for different host names, since I'm assuming DNS probably doesn't allow zone transfers, since most DNS servers don't anymore. Although they used to, you may have to start guessing, so I could do something like webmails that we find out here. So this shows us a dump of all the outstanding memory stuff. Okay, so that was all about finding network ranges. Now moving on to our next topic is using Google for reconnaissance. Now some people also call this Google hacking. Now, if you know how to use Google to exactly target and find what you are looking for, Google is an excellent tool for reconnaissance purposes. And today I'm going to show you how you could use Google exactly for your searches. So first of all, let's open a tab of Google. Let's open up here. So let's go to google.com. Okay, so now we're going to be talking about how we can use Google to actually gain some information or some targeted information. So this is in general called Google hacking. Now, when I say Google hacking, I'm not meaning by breaking into Google to steal information. I'm talking about making use of specific keywords that Google uses to get the most out of the queries that you submit. So for example, a pretty basic one is the use of quotations. You quote things in order to use specific phrases. Otherwise, Google will find pages that have instances of all those words rather than the words specifically together in particular order. So I'm going to pull this query up, and this shows a list of, let me just show it to you. So if you go index of, now this is showing us an index of all the films. Now this is basically all those index of sites that you want. So as you guys can see, this shows us an index of all sorts of films that are there. Now you can use the index of, and you see that we have also an index of downloads or something like that, hyphen.com/download. And it is an index of all sorts of stuff. Now you can go into some folder and check them out. G Jones, G Worthy, G Perico. I don't know what these are, but some sort of stuff. And this is how you can use Google. Now let me just show you some more tricks. So you can use this. So suppose you're using Google to find for something like a presentation. So you could use something like file type PPTX. And it'll search for every type of file there that is PPT. Okay, let's try some other site, .ppt. So config. Okay, so this brings up all the types of files that have some configs in them. So this is some gaming configuration, as we see. This is some digital configuration of Liverpool. Now you could also use something like this thing in URL, and you could use something like root, and this will give you all the things with root in their URL. So kingroot.n, digital trends, and how to root Android. So that's in the root, and suppose you want to say something like all in file type, or suppose you want some extension. So .ppt, .pptx, does that work? Let's search for JavaScript files. Okay, I think it's JS. Okay, that doesn't seem to work either. This shows us all the things with JS in it. No, it's just external JS. I'm doing this wrong. So you could use file type. So let's see, file type, and we go, see, doc. So these are all the documents that you could find with the file type thing. And you could also do JS, I guess. Yep, this will give you all the JavaScript files that are there. So this is how you can use Google to actually narrow down your searches. So suppose you want a particular set of keyword, and we want to make sure we get the passwords file from Google. Okay, so now let's go into more details about the various things you can find using Google hacking techniques. Now, while Google hacking techniques are really useful for just general searching in Google, they're also useful for penetration testers or ethical hackers. You can narrow down information that you get from Google. You get a specific list of systems that may be vulnerable. So we can do things like look for error pages that do in the title error. So I'm going to get a whole bunch of information. So suppose like we go in title and we say error. So as that we get all sorts of stuff, and we can do the minus Google part. So if you do a minus Google, it'll not show you the stuff that's from Google. So we get various documentation pages about different vendors and the errors that they support. So here's one doc about Oracle, about Java error. Where you know something more specific, we may be able to get errors about all sorts of other stuff. So this is how you could use the Google hacking technique to your own advantage if you're a penetration tester. Now let's also show you something called the Google hacking database. Now, this is very useful for an ethical hacker. Now, the Google hacking database was created several years ago by a guy called Johnny Long, who put this Google hacking database together to begin to compile a list of searches that would bring up interesting information. Now, Johnny has written a couple of books on Google hacking, so we're at the Google hacking database website here, and you can see them talk about Google Docs and all sorts of stuff. Now, you can see that we can do all sorts of searches like in URL, SAP, BC, BSP. This brings up some portal pages. Now, out here you can bring up some password, APS password in URL. Now, this will give you all sorts of stuff on Google. So suppose you go in URL, so like APS password. Now, you can get all sorts of stuff like which have passwords in their URL. So maybe you can just guess a password from there too. Now, that was Google hacking. So Google hacking entries, and they also have a number of categories and that you can look through to find some specific things. So you may be interested in, of course, and you can search specific information that you may be looking for with regards to a specific product. For example, let me just show you exploit database. These are all the types of stuff you can go through out here. And as you see, we have all sorts of stuff like this is an SQL injection thing. This is something regarding peer archive tars. So these let you get a foothold into some password cracking attempts, and you can do some brute force checking. And you can see here if it talks about the type of search it is and what it reveals. You can just click here on Google search, and it will actually bring up Google with a list of responses that Google generates. So let's look at this one here. This type is a log. So this is something about cross-site scripting logs, and we can also see some potty logs if I was not wrong. So there's some denial of service POC, and we can see a bunch of stuff. And if you continue to scroll down, there are a lot of interesting information in here. So somehow somebody's got a potty log that has logged a lot of information. They've got it up on a website, and it's basically a bunch of information that you can see. You can also get some surveillance videos sometimes, and you can look into them. And this is basically how you could use Google. So it's basically a list of queries that you can go through, and this is a very useful site if you're a penetration tester and looking for some help with your Google hacking terminologies. So that's it for Google hacking. Now let's move on. Okay, so now it's time for some networking fundamentals, and what better place to begin with TCP/IP. Now, we're going to be talking about the history of TCP/IP and the network that eventually morphed into the thing that we now call the internet. So this thing began in 1969, and it spun out of this government organization called ARPA, which Advanced Research Projects Agency, and they had an idea to create a computer network that was resilient to a certain type of military attacks. And the idea was to have this network that could survive certain types of war and warlike conditions. So ARPA sent out this request for proposals to BBN, which is Bolt, Baranek, and Newman, and they were previously an acoustical consulting company, and they won the contract to build what was called the ARPANET. The first connection was in 1969, so that's where we get the idea that the internet began in 1969, and the internet as we call it now didn't really begin, but ARPANET did. And ARPANET has a long history that goes through NSF Net in 1980s, and after ARPANET was sort of decommissioned, and a lot of other networks were folded into this thing called NSFNet that then turned into what we now call the internet. And once a lot of other networks were connected into its first protocol on the ARPANET, initially there were 18 to 22 protocols, which was very first protocol defining communication on ARPANET. And it was called 1822 protocol because BBN reported 1822, which describes how it worked shortly. And after that, there was this thing called the Network Control Program, and the network control program consisted of ARPANET's host-to-host protocol and an initial control protocol. Now, there's certainly not a direct correlation or an analogy here, but if you want to think about it in particular, where you could say that the ARPANET host-to-host protocol is kind of like UDP, and the initial connection protocol, or ICP, is kind of like TCP. So the host-to-host protocol provided a unidirectional flow control stream between hosts, which sounded a little bit like UDP. And ICP provided a bidirectional pair of streams between two hosts. And again, these aren't perfect analogies, but the host-to-host protocol is a little bit like UDP, and ICP is a little bit like TCP now. Now, the first router was called an interface message processor, and that was developed by BBN. It was actually a ruggedized Honeywell computer that had special interfaces and software. So the first router wasn't a ground-up built piece of hardware, but it was actually an existing piece of hardware that was specially purposed for this particular application. So Honeywell had this computer that they made out, and BBN took that and made some specific hardware interfaces and wrote some special software that allowed it to turn into this interface message processor, which passed messages over ARPANET from one location to another. So where did IP come in here in 1973? So IP came in here as well in 1973, as I just said, and a guy by the name of Vint Cerf and another guy by the name of Robert Kahn took the ideas of NCP and what the ARPANET was doing, and they tried to come up with some concepts that would work for the needs that the ARPANET had. And so by 1974, they had published a paper that was published by the IEEE, and they proposed some new protocols. They originally proposed a central protocol called TCP. Later on, TCP was broken into TCP and IP to get away from the monolithic concept that TCP was originally. So they broke it into more modular protocols, and thus you get TCP and IP. So how do we get to our version 4, which is IPv4, since that's the kind of internet that we're using right now? Version 6 is coming and has been coming for many, many years now, but we're still kind of version 4. So how did we get here between 1977 and 79? And we went through version 0 to 3 by 1979, and 1980 we started using version 4. And that's eventually became the de facto protocol on the internet. In 1983, when NCP was finally shut down, because of all the hosts on the ARPANET were using TCP/IP by that point in 1992. Work began on an IP next generation, and for a long time, all of the specifications in the RFCs talked about PNG eventually, and IPNG became known as IPv6. You may be wondering where IPv5 went. Well, it was a specially purposed protocol that had to do something with streaming and certainly not a widespread thing. One of the differences between IPv4 and IPv6 is that IPv6 has a 128-bit address, which gives us the ability to have some ridiculously large numbers of devices that have their own unique IP address. IPv4 by comparison has only 32-bit addresses, and as you've probably heard, we're well on our way to exhausting the number of IP addresses that are available, and we've done a lot of things over the years to conserve address space and reuse address space so we can continue to extending to the point till where we completely run off IPv4 addresses. Another thing about IPv6 is it attempts to fix some of the inherent issues in IP, and some of those has to do with security concerns, and there are certainly a number of flaws in IPv4. And when they started working on IP next generation or IPv6, they tried to address some of those concerns in some of those issues. And they may not have done it perfectly, but it was certainly an attempt. And IPv6 attempted to fix some of the issues that were inherently in IP. And so that's the history of TCP IP till where we've reached today. Okay, so now that we've discussed a brief history on TCP IP and how it came about to the TCP IP version 4, let's discuss the model itself. Now we're going to be discussing two models, and those are the OSI model and the TCP IP model. Now, as I said, we'll be talking about the OSI and TCP models for network protocols and the network stacks. OSI, first of all, is the one that you see out here. It's the one on the left-hand side of the screen, and OSI stands for Open Systems Interconnect. And in the late 1970s, they started working on a model for how a network stack and network protocols would look originally. The intent was to develop the model and then develop the protocols that went with it. But what ended up happening was after they developed the models, TCP/IP started really taking off. And the TCP/IP model was what went along with it and matched better what was going on with TCP/IP, which became the predominant protocol, and as a result, the OSI protocols never actually got developed. However, we still use the OSI model for a teaching tool, as well as a way of describing what's going on within the network stack. And in networked applications, you'll often hear people talking about different layers, like that's a layer 2 problem, or we're under a layer 3 space. Now, continuing through these lessons, I'll refer occasionally to the different layers, and when I do that, I'm referring to the OSI model. So let's take a look at the OSI model. Starting from the bottom, we have the physical layer, which is where all the physical stuff lives. The wires and cables and network interfaces and hubs, repeaters, switches, and all that sort of stuff. So all that sort of physical stuff is sitting in the physical layer. Now sitting above this is the data link layer, and that's where the Ethernet protocol, ATM protocol, frame relay, those sort of things live. Now I mentioned the switch below the physical. The switch lives at layer 1, but it operates at layer 2. And the reason it operates at layer 2 is because it looks at the data link address and the layer 2 or physical address, and that's not to be confused within the physical layer. It does get a little mixed up sometimes, and we refer to the MAC address. Now, the MAC address is not the physical address.
that I'm talking about. It is the message authentication code address on a system the MAC address on a system as a physical address because it lives on the physical interface and bound physically. However, that MAC address or media access control address lives at layer 2, at the data link layer. The network layer, which is right above at layer 3, that's where the IP lives, as well as ICMP, IPX, and from IPX, SPX suite of protocols from novel routers operate at layer 3, and at layer 4 above that is the transport layer. That's the TCP, UDP, and SPX again. From the IPX SPX suite of protocols. And above that is the session layer, and that's layer 5. And that's AppleTalk, SSH, as well as several other protocols. And then there's a presentation layer, which is layer 6. And you'll often see people refer to something like JPEG or MPEG as examples of protocols that live at that layer. Then there's a presentation layer, which is the final layer, which is layer 6, and you'll often see people refer to something like JPEG or MPEG as examples of protocol that live at that layer. And then they live at that layer, which is the presentation layer. Finally, we have layer 7, which is the application layer, and that's HTTP, FTP, SMTP, and similar application protocols, whose responsibility is to deliver and use a functionality. So that's basically the OSI model, and that's the 7 layers of the OSI model. And there's some important thing to note here. That is, when we are putting packets onto the wire, the packets get built from top of the stack down by from the top of the stack to the bottom of the stack, which is why it's called a stack. Each layer sits on top of the other, and the application layer is responsible for beginning the process, and then that follows through the presentation session and transport layer and down through the network data link until we finally drop it on the wire at the physical layer. When it's received from the network, it goes from the bottom up and we receive it on the physical and it gets handled by the data link and then the network and till the application layer. So basically, when a packet is coming in, it comes in from the application, goes out from the physical, and then when it's going out also, it goes from the physical through the data link, then the network, transport session, presentation, and application, and finally to the target system. Now, what we're dealing with is an encapsulation process. So at every layer on the way down the different layers, add bits of information to the datagram or the packet. So that's when it gets to the other side. Each layer knows where its demarcation point is. While it may seem obvious, each layer talks to the same layer on the other side. So when we drop a packet out onto the wire, the physical layer talks to the physical layer, and in other words, the electrical bits that get transmitted by the network interface on the first system are received on the second system. On the second system, the layer 2 headers that were put by the first system get removed and handled as necessary. Same thing at the network layer. It's the network layer that puts the IP header, and it's the network layer that removes the IP header and determines what to do from there, and so on again. While it may seem obvious, it's an important distinction to recognize that each layer talks to each layer. While it may seem obvious, it's an important distinction to recognize that each layer talks to each layer. And when you're building a packet, you go down through the stack, and when you're receiving, you come up through the stack. And again, it's called a stack because you keep pushing things on top of the packet and they get popped off the other side. So that was detailed and brief working on how the OSI model is set up and how the OSI model works. Now let's move on to the TCP IP model, which is on the right hand side. And you'll notice that there's a really big difference here. That being that there are only 4 layers in the TCP IP model as compared with the 7 layers of the OSI model. Now we have the network access layer, the internet layer, the transport layer, and the application layer, and the functionality. Now we have the access layer, the internet layer, the transport layer, and the application layer. The functionality that the stack provides is the same, and in other words, you're not going to get less functionality out of the TCP IP model. It's just that they've changed where different functionality resides and where the demarcation point between the different layers are. So there are only 4 layers in the TCP IP model, which means there are a couple of layers that have taken in functions from some of the OSI models, and we can get into that right here. The difference between the models at the network access layer in the TCP IP model that consists of the physical and the data link layer from the OSI model. So on the right here, you see the network access layer that takes into the account the physical and the data link layers from the OSI model. On the left-hand side, similarly, the application layer from the TCP IP model encompasses all the session presentation and the application layer of the OSI model. So on the right, the very top box, the application layer, encompasses the session presentation and application layer. And on the left-hand side, that of course leaves the transport layer to be the same. And in the OSI model, they call it the network layer. And in the TCP/IP model, it's called the internet layer. Same sort of thing, that's where the IP lives. And even though it's called the internet layer as compared to the network layer, It's the same sort of functionality. So those are the really big differences between OSI and TCP/IP model. Anytime I refer to layers through the course of this video, that I'm going to be referring to the OSI model, and in part because it makes it easier to differentiate the different functionality. If I were to say layer 1 function in the TCP/IP model, you would necessarily know if I was talking about a physical thing or a data link thing. Since there's more granularity in the OSI model, it's better to talk about the functionality in terms of the layers in the OSI model, and that's the predominant model, the OSI model and the TCP/IP model for network stacks, network protocols, and applications.
Okay, so now that we've discussed the TCP/IP model, let's go over another important protocol, and that is UDP. So what you see out here on your screen right now is Wireshark, and we'll be going over the uses of Wireshark and what it's useful for in the upcoming lessons. But for now, let me just show you a UDP packet. Okay, so before we get into the analysis of the packet while it's still filtering, let me just tell you a little bit about UDP. So UDP is a protocol in the TCP/IP suite of protocols. It's in the network layer. That's the network layer in the OSI. So a 7-layer reference model, the IP network layer carries the IP address, and that has information about how to get packets to its destination. The transport layer sits on top of the network layer, and that carries information about how to differentiate network layer applications. And that information about how those network application gets differentiated is in the form of ports. So the transport layer has ports, and the network layer has, in this case, an IP address. And UDP is a transport layer protocol. And UDP stands for User Datagram Protocol, and it's often called connectionless or sometimes unreliable. Now, unreliable doesn't mean that you can't really rely on it. Unreliable means that you can't trust that what you send is reaching the other side. So what means actually that there's nothing in the protocol that says it's going to guarantee that the datagram that you send or the packet that you send is going to get where you want to send it. So the protocol has no sort of safety feature like that. So you shouldn't use this protocol, that is UDP, if you want some sort of safety net. And if you needed that type of safety net, you would have to write it into your own application. So basically UDP is a fast protocol, and that's one of the reasons why it's good. It's also one of the reasons why it's unreliable, because in order to get that speed, you don't have all of the error checking and validation that messages are getting there. So because it's fast, it's good for things like games and for real-time voice and video, anything where speed is important, and you would use UDP. So right here, I have a packet capture. So I'm using Wireshark to capture some packets, and let's check out a UDP packet. So out here you see that there are some frames that says it's 167 bytes on wire, 167 bytes have been captured. But we're not really interested in the frame part. We're interested in the user datagram protocol part. So out here, you can see that the source port is 1853 and the destination port is 52081. Now, it has a length and it has a checksum and stuff. So as you guys see out here, well, we don't really see a bunch of information. What you only see is the source port and the destination port, the length, and there's also a checksum. So UDP doesn't come with an awful lot of headers because it doesn't need any of the things that you see in the other packet headers. The only thing it needs is to tell you how to get the application on the receiving host, and that's where the destination port comes in. And once the message gets to the destination needs to know how to communicate back to the originator, and that would be through the source port or a return message. So a return message would convert the source port to a destination port and send back to that port in order to communicate with the originator. So we have a source port and destination port, and the length is a minimal amount of checking, and to make sure that if the packet that you received is different from the length that's specified in the UDP header, then there may have been something wrong. So you may want to discard the message to check for more messages. So the checksum also makes sure that nothing in the middle was tampered with, although if there's some sort of man-in-the-middle attack or something like that, a checksum is pretty easy to manufacture after you've altered the packet. So you can see here in the message that there's a number of UDP packets. Some of them just say UDP. The one look at happens to be from some Skype application, I guess. So talking to Skype servers, and we've already got the DNS. Now DNS also needs some fast response times because you don't want to spend a lot of time looking up information about servers that you're going to before, because just to go to them. So DNS servers throw out their queries onto the wire using UDP hopping to get fast sponsors. They don't want to spend a lot of time setting up connections and during all the negotiating that comes with a protocol like TCP, for example. So here you see that the DNS is using UDP, and what we've got here is another UDP packet with port destination and all sorts of stuff. So you can see it out here. So you can see the checksum, it's unverified checksum status. So you can check out all sorts of stuff using Wireshark. So that was about UDP, or the User Datagram Protocol. Okay, so now that we're done with the user datagram protocol, let's talk about addressing modes. So addressing modes is how you address a packet to your different destinations. So there are three kinds of addressing modes. The first kind of addressing mode is unicast. This is a pretty simple one to understand. So there is one destination and one source, and the source sends the packet to the destination. And it depends on the protocol that you're using to actually address. So if it's something like TCP/IP, you're probably using a bidirectional stream, so the blue computer can talk to the red computer, and the red computer can talk back to the blue computer. But you can also use a UDP stream, which is like one directional stream. So I'm not sure if I'm using the correct word. So it's a stream that's in one direction. I guess I'm driving home the point here. So if it's a UDP, only blue is talking, and when blue stops talking, then red can talk. But if it's TCP/IP, blue and red can talk simultaneously at the same time. Now, moving on, there's also broadcast. Now, broadcast means that you are sending your packet to everybody on the network. So, broadcast messages are very common from mobile network providers. So, when you get those advertisements saying something like you have a new postpaid plan from Vodafone or Airtel or something like that, those are broadcast messages. So, it's one server that is sending out one single message to all the other systems. Now there's also multicast. Now multicast is like broadcast but selective. Now multicast is used for actually casting your screen to multiple people. So something like screen share, when you're doing it with multiple people, is multicast because you have the option to not show a particular computer what you are actually sharing. So those are the three modes of addressing: unicast, broadcast, and multicast. Okay, now moving on, let's look into the tool that we just used to understand UDP, that is Wireshark. So what exactly is Wireshark? So this utility called Wireshark is a packet capture utility, meaning that it grabs data that's either going out or coming in of a specific network. And there are a number of reasons why this may be useful or important. One of the reasons why it's really important is what's going on in the network is always accurate. In other words, you can't mess around with things once they're on the network, or you can't lie about something that's actually on the network as compared with applications and their logs, which can be misleading or inaccurate. Or if an attacker gets into an application, they may be able to alter the logging. Now, several other behaviors that make it difficult to see what's really going on. And the network, you can really see what's going on once it hits the wire. It's on the wire, and you can't change that fact. Now, once it hits the wire, so we're going to do here is a quick packet capture. So let me just open up Wireshark for you guys. So as you guys can see, I have already Wireshark open for us. Let me just remove this UDP filter that was there. So Wireshark is recapturing. So let us go over the stuff that you can see on the screen. Some important features of Wireshark so that we can use it later. So what I'm doing here is a quick packet capture, and I'm going to show some of the important features of Wireshark so that we can use it later on. Now, when we're starting to do some more significant work, I select the interface that I'm using primarily, which is my Wi-Fi, and I'm going to go over here and we'll bring up a Google page so that we can see what's happening on the network. So let me just quickly open up a Google page. As you guys can see, it's capturing a bunch of data that's going around here. Now let me just open up a Google page, and that's going to send up some data. Let's go back. So it's grabbing a whole bunch of stuff off the network. I'm just going to stop that. I'm going to go back and take a look at some of the messages here. So some of the features of Wireshark, as you can see on the top part of the screen, here there's a window that says number, time, source, destination, protocol, length, and info. And those are all of the packets that have been captured. And their numbering starting from 1, and the time has to do with being relative to the point that we've started capturing. And you'll see the source and destination addresses, and the protocol, the length of the packet in bytes, and some information about the packet. At the bottom of the screen, you'll see detailed information about the packet that has been selected. So suppose I'm still selecting this TCP packet out here. So we can go through the frames. The frame also has some interface IDs, the encapsulation type, and all sorts of information is there about the frame. Then we can look at the source port, the destination port, the sequence number, the flag set, the checksums. We can basically check everything about a packet because this is a packet analyzer and a packet sniffer. Now you'll see some detailed information about the packet that has been selected. So I'm going to select, so as I've selected this TCP IP packet,
we see that in the middle frame it says frame 290. It means that it has a 290 A flag packet, and the packet that was captured is 66 bytes. And we grab 66 bytes and it's 528 bits later. So what you see out here was the source and the destination MAC address of the layer to layer address, and then you can see the IP address of both source and destination. And it says it's a TCP packet, gives us a source port, destination port, and we can start drilling down into different bits of the packet. And you can see when I select a particular section of the packet down at the very bottom, you can see what's actually a hex dump of the packet, and on the right hand side is the ASCII. So this is the hex dump, and this is the ASCII that you're looking at. What's really cool about Wireshark is it really pulls the packet into its different layers that we have spoken about, the different layers of the OSI and the TCP/IP model. And the packets are put into different layers, and there's a couple of different models that we can talk about with that. What Wireshark does really nicely is it demonstrates those layers for us, as we can see here. It is actually 4 layers, and in this particular packet here, we can also do something. So I've got a Google Web request. So what I want to do here is I want to filter based on HTTP. So I find a filter. So let's see. We can do an HTTP. And what I see here is it gets text input and it's going to get an image. So that's a PNG image. And this is a request to get the icon that's going to be displayed in the address bar. So you also see something called ARP out here, which I'll be talking about very soon. So let just the filtering be done. Now in the web browser, it's a favicon.ico that I can do here. I can select, analyze, and follow TCP streams. You can see all the requests related to this particular request, and it breaks them down very nicely. So you can see we've sent some requests to Spotify because I've been using Spotify to actually listen to some music. Then you can see all sorts of stuff like this was something to some not found place. So let's just take the Spotify one, and you can see that we get a bunch of information from the Spotify thing at least. You can see the destination, the source. It's an Intel Core machine. So the first part of the MAC address, the first few digits, lets you tell if it's what is the vendor ID. So Intel has its own vendor ID. So F496 probably tells us that that's an Intel Core. So Wireshark does this very neat little thing that it also tells us from the MAC address what type of machine you're sending your packets to from the MAC address itself. So it's coming from a Sophos 4C and going to an Intel Core, and the type is IPv4. So that was all about Wireshark. You can use it extraneously for packet sniffing and packet analysis. Packet analysis comes very handy when you're trying to actually figure out how to do some stuff like IDS evasion, where you want to craft your own packets and you want to analyze the packets that are going into the IDS system to see which packets are actually getting detected as some intrusion. So you can craft your packet in a relative manner so that it doesn't get actually detected by the IDS system. So this is a very nifty little tool. We'll be talking about how you can craft your own packets just in a little while, but for now, let's move ahead. Okay, so now that we are done with our small little introduction and a brief use and history of Wireshark, now let's move on to our next topic for the video, that is DHCP. Okay, so DHCP is a protocol and it stands for Dynamic Host Configuration Protocol. So DHCP is a network management protocol used to dynamically assign an internet protocol address to any device on a network so they can communicate using IP. Now, DHCP automates and centrally manages these configurations rather than requiring some network administrator to manually assign the IP addresses to all the network devices. So DHCP can be implemented on small local networks as well as large enterprises. Now, DHCP will assign new IP addresses in each location when devices are moved from place to place, which means network administrators do not have to manually initially configure each device with a valid IP address. So if a device with a new IP address is moved to a new location of the network, it doesn't need any sort of reconfiguration. So versions of DHCP are available for use in the Internet Protocol version 4 and Internet Protocol version 6. Now, as you see on your screen is a very simplistic diagram on how DHCP works. So let me just run you down. DHCP runs at the application layer of the TCP IP protocol stack to dynamically assign IP addresses to DHCP clients and to allocate TCP IP configuration information to DHCP clients. This includes subnet mask information, default gateways, IP addresses, domain name systems, and addresses. So DHCP is a client-server protocol in which servers manage a pool of unique IP addresses
as well as information about client configuration parameters, and assign addresses out of those address pools. Now, DHCP-enabled clients send a request to the DHCP server whenever they connect to a network. The clients configured with DHCP broadcasts a request to the DHCP server and the request network configuration information for a local network to which they're attached. A client typically broadcasts a query for this information immediately after booting up. The DHCP server responds to the client request by providing IP configuration information previously specified by a network administrator. Now, this includes a specific IP address as well as for the time period, also called a lease, for which the allocation is valid. When refreshing an assignment, a DHCP client requests the same parameters, but the DHCP server may assign a new IP address based on the policies set by the administrator. Now, a DHCP server manages a record of all the IP addresses it allocates to networks, nodes. If a node is reallocated in the network, the server identifies it using its media access control address. Now, which prevents accidental configuring multiple devices with the same IP address. Now, DHCP is not a routable protocol, nor is it a secure one. DHCP is limited to a specific local area network, which means a single DHCP server per LAN is adequate. Now, larger networks may have a wide area network containing multiple individual locations depending on the connections between these points and the number of clients in each location. Multiple DHCP servers can be set up to handle the distribution of addresses. Now, if network administrators want a DHCP server to provide addressing to multiple subnets on a given network, they must configure DHCP relay services located on interconnecting routers that DHCP requests to have to cross. Now, these agents relay messages between DHCP client and servers. DHCP also lacks any built-in mechanism that would allow clients and servers to authenticate each other. Both are vulnerable to deception and to attack, where rogue clients can exhaust a DHCP server's pool. Okay, so let's move on to our next topic, and that is why use DHCP. So I just told you that DHCP doesn't really have any sort of authentication, so it can be fooled really easily. So what are the advantages of using DHCP? So DHCP offers quite a lot of advantages. Firstly is IP address management. A primary advantage of DHCP is easier management of IP addresses. In a network without DHCP, you must manually assign IP address. You must be careful to assign unique IP addresses to each client and to configure each client individually. If a client moves to a different network, you must make manual modifications for that client. Now, when DHCP is enabled, the DHCP server manages the assigning of IP addresses without the administrator's intervention. Clients can move to other subnets without manual reconfiguration because they obtain from a DHCP server new client information appropriate for the new network. Now, apart from that, you can say that DHCP also provides a centralized network client configuration. It has support for boot TP clients. It supports the local clients and remote clients. It supports network booting. And also, it has a support for a large network, and not only for short, like small scale networks, but for larger networks as well. So that way, you see DHCP has a wide array of advantages, even though it doesn't really have some authentication. So because of these advantages, DHCP finds widespread use in a lot of organizations. Okay, so that winds up DHCP for us. So let us go into the history of cryptography now. So let me give you a brief history of cryptography. Now, cryptography actually goes back several thousand years before, shortly after people began to find ways to communicate. There were some of us who were finding ways to make the understanding of that communication difficult so that other people couldn't understand what was going on. And this led to the development of Caesar cipher that was developed by Julius Caesar. And it's a simple rotation cipher. And by that, I mean that you rotate a portion of the key in order to generate the algorithm. So here's an example. We've got two rows of letters and that are alphabetical in order, and means we basically written the alphabets down and the second row is shifted by three letters. So a B is a Z actually, because if you move that way, a B is a Z from the first row gets shifted back to the second row, and then the letter D becomes the letter C. That's an example of how encryption works. So if you try to encrypt a word like hello, it would look completely gibberish after it came out of that algorithm. So if you count the letters out, you can see that the letter H can be translated to letter L. So that's a Caesar cipher. Now you must have heard of things like ROT13, which means that you rotate the 13 letters instead of 3 letters. That's what we can do here again. And this is just a simple rotation cipher or Caesar cipher that's
what, of course, the rod stands for. It's rotate or rotation. Now, coming forward a couple thousand years, we have the Enigma cipher. Now, it's important to note that the Enigma is not the word given to this particular cipher by the people who developed it. It's actually the word given to it by the people who were trying to crack it. The Enigma cipher is a German cipher. They developed this cipher and a machine that was capable of encrypting and decrypting messages so that they could messages to and from different battlefields and war fronts, which is similar to the Caesar cipher. Caesar used it to communicate with his battlefield generals, and the same thing with the Germans. You've got to get messages from headquarters down to where the people are actually fighting, and you don't want it to get intercepted in between by the enemy. So therefore, you use encryption. And lots of energy was spent by the Allies, in particular the British, trying to decrypt the messages. One of the first instances that we are aware of where a machine was used to do the actual encryption, and we're going to come ahead a few decades now into the 1970s, where it was felt that there was a need for a digital encryption standard. Now, the National Institute of Standards and Technology is responsible for that sort of thing, so they put out a proposal for this digital encryption standard. And an encryption algorithm, what ended up happening was IBM came up with this encryption algorithm that was based on the Lucifer cipher. That was one their people had been working on a couple of years previously in 1974. And they put this proposal together based on the Lucifer cipher. And in 1977, that proposal for an encryption algorithm was the one that was chosen to be the digital encryption standard. And so that came to be known as DES over time. And it became apparent that there was a problem with DES, and that was it only had a 56-bit key size. And while in the 1970s that was considered adequate to defend against brute forcing and breaking of code, by 1990s it was no longer considered adequate, and there was a need for something more, and it took time to develop. Something that would last long for some long period of time. And so in the meantime, a stopgap was developed, and this stopgap is what we call the triple DES. The reason it's called triple DES is you apply the DES algorithm three times in different ways, and you use three different keys in order to do that. So here's how triple DES works. Your first 56-bit key is used to encrypt the plain text, just like you would do with the standard digital encryption standard algorithm, where it changes, and you take that ciphertext that's returned from the first round of encryption, and you apply the decryption algorithm to the ciphertext. However, the key thing to note is that you don't use the key that you use to encrypt. You don't use the first key to decrypt it because otherwise you'll get the plain text back. So what you do is you use a second key with the decryption algorithm against the ciphertext from the first round. So now you've got some ciphertext that has been encrypted with one key and decrypted with the second key, and we take the ciphertext from that and we apply a third key using the encryption portion of the algorithm to that cipher. Encryption portion of the algorithm to that ciphertext to receive a whole new set of ciphertext, obviously. To do the decryption, you do the third key and decrypt it. With the second key, you encrypt it. And then with the first key, you decrypt it. And so you do reverse order and the reverse algorithm at each step to apply triple DES. So we get an effective key size of about 168 bits, but it's still only 56 bits at a time. Now, I said triple DES was only a stopgap. What we were really looking for was the advanced encryption standard once again. And NIST requested proposals so that they could replace the digital encryption standard in 2001. After several thousands of looking for algorithms and looking them over, getting them evaluated and getting them looked into, NIST selected an algorithm and it was put together by a couple of mathematicians. The algorithm was called Reindoll, and that became the Advanced Encryption Standard, or AES. It's one of the most advantages of AES is it supports multiple key lengths. Currently, what you'll typically see is as we are using 128-bit keys. However, AES supports up to 256-bit keys. So if we get to the point where 128-bit isn't enough, we can move all the way up to 256 bits of keying material. So cryptography has a really long history. Currently, we are in a state where we have a reasonably stable encryption standard in AES. But the history of cryptography shows that with every set of encryption, eventually people find a way to crack it. Okay, so that was a brief history of cryptography. Now, what I want to do is let's go over and talk about AES, triple DES, and DES in themselves because they are some really key cryptographic moments in history. Because there are some really key historic moments in the history of cryptography. Now, we're going to talk about the different types of cryptographic ciphers, and primarily we're going to be talking about DES, triple DES, and AES. Now, DES is the digital encryption standard. It was developed by IBM in the 1970s, and originally it was cryptographic cipher named Lucifer.
And after some modifications, IBM proposed it as the digital encryption standard, and it was selected by the digital encryption standard. Ever since then, it's been known as DES. Now, one thing that caused a little bit of controversy was during the process of selection, NSA requested some changes, and it hasn't been particularly clear what changes were requested by the NSA. There has been some speculation that wondered if the NSA was requesting a backdoor into this digital encryption standard, which would allow them to look at encrypted messages in the clear. So basically, it would always give the NSA the ability to decrypt DES encrypted messages. It remained the encryption standard for the next couple of decades or so. So, what is DES and how does it work? Basically, it uses 56-bit keys rather than a stream cipher. It's a block cipher and it uses 64-bit blocks. And in 1998, DES was effectively broken. When a DES encrypted message was cracked in 3 days, a year later, a network of 10,000 systems around the world cracked the DES encrypted message in less than a day. And it's just gotten worse since then, with modern computing power being what it is. Since DES was actually created, we already had come to the realization that we needed something else. So along came triple DES. Now, triple DES isn't 3 times the strength of DES necessarily. It applies DES just 3 times. And what I mean by that is what we do is we take a plain text message, then let's call that P, and we're going to use a key called K1, and we're going to use that key to encrypt the message. And use a key that we will call K1, and we're going to use that to encrypt the message. And that's going to result in the ciphertext, and we'll call the C1. So C1, the output of the first round of encryption, we're going to apply a second key, and we'll call that K2 with that second key. And we're going to go through a decryption process on C1. Since it's the wrong key, we're not going to get plain text out on the other end. What we're going to get is another round of ciphertext, and we will call this C2. What we do with C2, we are going to apply a third key, and we will call this K3, and we're going to encrypt ciphertext C2, and that's going to result in another round of ciphertext, and we will call that C3. So we have 3 different keys applied in 2 different ways. So with key 1 and key 3, we do a round of encryption, and with key 2, we do a round of decryption. So it's an encrypt, decrypt, encrypt process with separate keys. While that doesn't really yield a full 168-bit key size, the 3 rounds of encryption yields an effective key size of 168 bits because you have to find 356-bit keys. So speaking of that, technical detail for triple DES, we're still using the DES block cipher with 56-bit keys, but since we've got 3 different keys, we get an effective length of around 168 bits. Triple DES was really just a stopgap measure. We knew that if DES could be broken, triple DES could surely be broken with just some more time, I guess. And so the NIST was trying to request a standard that was in 1999, and in 2001, NIST published an algorithm that was called AES. So this algorithm that was originally called Raindoll was published by NIST as the Advanced Encryption Standard. Some technical specifications about AES is that the original Raindoll algorithm specified variable block sizes and key lengths. And as long as those block sizes and key lengths were multiples of 32 bits, so 32, 64, 96, and so on, you could use those block sizes and key lengths. When AES was published, AES specified a fixed 128-bit block size and key length of 128, 192, and 256. AES with 3 different key lengths, but 1 block size. And that's a little bit of detail about DES, triple DES, and AES. So when AES was published, AES specified a fixed 128-bit block size and a key length of 128, 192, and 256 bits. So we've got with AES 3 different key lengths, but 1 block size. And that was a little bit of detail about DES, triple DES, and AES. We'll use some of these in doing some hands-on work in the subsequent part of this video. Okay, so now that I've given you a brief history of how we have reached to the encryption standards that we are following today, that is the Advanced Encryption Standard, let's go ahead and talk a little bit more about DES, triple DES, and AES. So DES is a digital encryption standard. It was developed by IBM in the 1970s, and originally it was a cryptographic cipher named Lucifer. And after some modifications, IBM proposed it as the digital encryption standard. It was selected to be the digital encryption standard, and ever since then, it's been known as DES or DES. One thing that caused a little bit of controversy was during the process of selection, the NSA requested some changes, and it hasn't been particularly clear what changes were requested by the NSA. There has been some sort of speculation that wondered if the NSA was requesting a backdoor into this digital encryption standard, which would allow them to look at encrypted messages in the clear. So basically, it would always give the NSA the ability to decrypt
DES encrypted messages. It remained the encryption standard for the next couple of decades or so. And what is DES and how does it work? Now, DES remained the digital standard for encryption for the next couple of decades. So, what does it do and how does it work? So, basically, it uses a 56-bit key rather than a stream cipher. It's a block cipher and it uses 64-bit blocks. And in 1998, if you know, DES was effectively broken when a DES encrypted message was cracked in 3 days. And then a year later, a network of 10,000 systems around the world cracked a DES encrypted message in less than a day. And it's just gotten worse since then with modern computing being what it is today. Now, since DES was created and broken, we knew we needed something. And what came in between advanced encryption standards and DES is triple DES. Now, triple DES isn't 3 times the strength of DES necessarily. It's really DES applied 3 times. And what I mean by that is we take a plain text message, then let's call that P, and we're going to use a key called K1. And we're going to use that key to encrypt the message, and that's going to result in the ciphertext 1. So we'll call that C1. Now, C1 is the output of the first round of encryption, and we're going to apply a second key called K2. And with that second key, we are going to go through a decryption process on C1. Now, since it's the wrong key, we are not going to get the plain text out of the decryption process. On the other end, we are going to get another round of ciphertext, and we're going to call that C2. Now with C2, we are going to apply a third key, and we are going to call that K3, and we're going to encrypt ciphertext C2, and that's going to result in ciphertext C3. So we have 3 different keys applied in 2 different ways. So with key 1, key 3, we do a round of encryption. With key 2, we do a round of decryption. So it's basically an encrypt, decrypt, encrypt process with 3 separate keys. But what it does really is it doesn't really yield a 168-bit key size, because in effectiveness, it's basically 56-bit keys that are being used thrice, whether it be 3 different keys. So in effectiveness, you could say that it's a 168-bit key, but it is not the same strength, because people realize that triple DES can be easily broken, because if DES is broken, you can do the same thing with 3 different ways with whatever key that you use. So it just takes longer time to decrypt if you don't know the key, and if you are just using a brute force attack, you know that triple DES can be broken if DES can be broken. So triple DES was literally a stopgap between DES and AES, because people knew that we needed something more than triple DES. And for this, the NIST, or the National Institute of Standards and Technology, in 2001, they chose AES as the algorithm that is now called the Advanced Encryption Algorithm. So it was originally called the Raindoll algorithm. And the main thing about the Raindoll algorithm and the Advanced Encryption Standard algorithm is that the Raindoll algorithm specifically states in its papers that it has a variable block size and a variable key size as long as they are in multiples of 32. So 32, 64, 96, like that. But what AES does differently is that it gives you one block size, that is 128 bits, and it gives you 3 different key sizes, that is 128, 192, and 256. So with AES, 3 different key lengths, but one block size. Okay, so that was a little bit more information on AES, DES, and triple DES. And we are going to be using this information in some subsequent lessons. Okay, now moving on. Okay, so now that we've discussed the different history of cryptography and the more important cryptographic algorithms, let's discuss the different types of cryptography. Now, the first type of cryptography I'm going to talk about is symmetric cryptography. And by symmetric cryptography, I mean that the key is the same for encrypting or decrypting. So I use the same key whether I am encrypting the data or decrypting the data. One of the things about symmetric key cryptography is that they use a shorter key length than for asymmetric cryptography, which I'll get into a couple of minutes. It's also faster than asymmetric, and you can use algorithms like DES or AES, as those are both symmetric key cryptography algorithms, and you can use a utility like AES script. Let me just demonstrate how symmetric key cryptography works. So for this, we can use a tool called AES script. So in AES script is actually available for Linux and Windows and Mac, all the systems. So I'm using it on the Windows one, and I'm using the console version. So first of all, I have a text file called text.txt. So let me just show that to you. So as you guys can see, I have this thing called text.txt. Now to do text.txt, let me just show what text.txt contains. So as you guys can see, it has a sentence called "The quick brown fox jumped over the lazy dog." So that's the sentence that has all the alphabets in the English language, rather.
So now we are going to try and encrypt it. So we can use something like AES or DES because both of them are symmetric key ciphers, symmetric key algorithms rather. So we are using AES in this case. So what we're going to do is say AES script. We're going to encrypt it and we're going to use a password of, let's say, Pokemon. So we're going to call it Pokemon and we're going to do text.txt. We're going to encrypt that file. So now we have encrypted that file. Now let's go see. We must be having a new file. So this is called text.txt.aes. So that is our encrypted file, and this is what we would generally send over the network if we are sending it to anybody. So let's assume the person who's received it also knows our encryption algorithm. I mean, encryption algorithm and the key that goes along with it. So let's try to decrypt it now. Now, before I decrypt it, let me just show you what an encrypted message looks like. So this is what the ciphertext looks like. Type AS, no, text.txt.aes. So yeah, as you guys can see, the Windows console can't really read everything, but if I were to go here, if I were to just go into the file and just edit Notepad++, you'll see that it's a bunch of crap. You really can't make out anything. What is being made here, we can't really decipher much. So that's the point of using encryption. Now, if you were to decrypt it, all we have to do is AES script. We're trying to decrypt. We're trying to give the password is going to be, what was the password? Pokemon. Okay, so, and we're going to try and decrypt text.txt.aes. Now let's dir that again. Okay, so that just decrypts our message for us. So this is how you would use AES script for encryption and decryption. So that just decrypts it, and that's how you would use symmetric key encryption to encrypt a file for this example. Symmetric key uses the either a stream cipher or a block cipher, and the differences between stream or block ciphers is that block takes a block of bits at a time and it's a fixed length. So for example, 64 bits, if I were to use a block cipher with 64 bits, I would need to take in 64 bits before I could start encrypting. Now, if I didn't have 64 bits to encrypt, I would have to fill it with padding in order to get up to 64 bits a stream cipher. On the other hand, it will encrypt a bit at a time, so it doesn't matter how many bits you've got. You don't need to have some multiple of the block length in order to encrypt without padding. And another type of cryptography is asymmetric. Now, asymmetric, as you would expect, uses two different keys, and that's where we have public key and private key. Asymmetric key cryptography uses a longer key length, and it also has more computation, and the encryption process is slower with a symmetric key encryption. And the encryption process is slower than with the symmetric key encryption. One of the uses for symmetric key is for signing documents or emails, for example, where I would have the private key sign something and the public key would be used to verify a signature. And another reason for using asymmetric key encryption is to ensure that you got it from who actually sent it. Since you've got two keys, you always know who the other end of the equation is. Where with symmetric key, since it's just one key, if you can intercept the key, you can decrypt and also encrypt messages. And so if somebody can figure out the key, you can break into a communication stream using symmetric key encryption. So asymmetric gives you the advantage of ensuring that the other end is who the other end says, and they are, since they're the only ones who should have the private key. And in this particular instance, in practice, however, hybrid encryption models tend to be used, and that's where you would use asymmetric encryption to encrypt asymmetric session keys. So basically, you encrypt the message that you are sending using symmetric key encryption, and then when you're exchanging the key with somebody else, you use asymmetric key encryption. So this is going to be a slower process. You probably won't want to use it for smaller files. In order to do that, fortunately, the file example that I have is a smaller one. So I'm going to try and generate a key right now. So for this, we have to head over to our Ubuntu system. So let's see. Let me show you how public key encryption actually works. And we are going to first create a key. So let me just clear this out for you. So first of all, let's create a file and let's call that text.txt. Now, if you see, we are going to edit text.txt to have some file. So have some text in it. So there seems to be a warning with the GTK. I'll just use echo instead. So now let's see if that is in our file. Okay, so let me just show you how asymmetric key encryption or public key cryptography works. So first of all, we need a text file. So let me see. Do we have a text file? So there seems to be a text.txt. So let's see what this text.txt says. So it says that this is a random text file. Now what we want to do is we want to create a public key first. So I'm going to use OpenSSL for doing this. So we go OpenSSL and we are going to use it with RSA. So we're trying to generate a key, so gen RSA, and we're going to use des3 to use this, and we're going to output it into a file called private.key. So we are also going to be using a 4096 bit. So this is going to be our private key. So this will create a private key using RSA algorithm. So let it work its way out. So first of all, it's asking me for a passphrase now. So since you can protect your keys with a passphrase, so I'm just going to use my name. Okay, so now we see if we ls and we have a private dot key, I guess. Yep. So we have this private dot key. Now we're using this private key, we are going to generate a public key. So for this, I'm again going to be using OpenSSL. And OpenSSL is a Unix based, so you will need a Unix system. So you go RSAUTL, that's RSA utility, and what we want to do is encrypt, and we want the public key in key, and we want to use the public key that we just generated. I'm sorry, guys. So we are going to be using RSA. So first of all, we need to generate a public key. So for that, we use the private key. So we will give the private key as an argument after the in flag. So private.key, and we are trying to get out a public key. So pub out, and we're going to call it public.key. Okay, so there seems to be. Okay, I messed it up a little. I forgot to give the output. So you go out, and then you use public.key. So it's asking me for a passphrase, and now it's writing the RSA key, and since the password was correct, we have a public key too. So if you see, now we have a public key and a private key. So we are going to encrypt our file using the public key. So we go OpenSSL, and we go RSAUTL, and we go encrypt, and we can do pub in. So we are going to use the public key, and we want to put the text.txt as the file to be encrypted. So text.txt, and what we want to output is an encrypted file. So encrypted.txt. Okay, I call it OpenSLL. I need to go and edit that out now. Yeah, so that makes it a correct command. And now we have an encrypted file. So let's see. ls and yep, encrypted.txt. So if we just cut that out, so we see it's a bunch of garbage and we really can't read it unless we decrypt it. So for decrypting the key, all we have to do is again use OpenSSL. Let's clear this out first. So OpenSSL, and we are going to be using the RSA utility again. So RSA UTL, we're going to decrypt this time. So we go with the decrypt flag, and then we are going to be giving the in key, and that is going to be the private key. And what we want to decrypt is encrypted.txt, and what we want to output it is as, let's say, plaintext.txt. So it's going to ask me for my passphrase, which is my name, and I've entered the passphrase, and now we have a plaintext.txt. Now, if we are to go and ls, we see that we have a plaintext.txt out here, just beside info.txt. Now let me just cat that out. So plaintext.txt. So this is a random text file. And if we go up, we see that it was a bunch of garbage, and before that, it was a random text file. Now you can also run this command called diff plaintext.txt text.txt. So this will give you a difference in the text strings. So it's 0, so it gives you that's the difference. So both the files are the same, and that's how public key cryptography works and how symmetric key cryptography works. Okay, now moving ahead of cryptography, let's talk about certificates. Okay, so now that we're done with cryptography, let's talk about digital certificates. So what is a digital certificate? Well, a digital certificate is an electronic password that allows a person, organization to exchange data securely over the internet using public key infrastructure. So digital certificate is also known as a public key certificate or an identity certificate. Now, digital certificates are a means by which consumers and businesses can utilize the security application of public key infrastructure. Public key infrastructure comprises of the technology to enable and secure e-commerce and internet-based communication. So, what kind of security does a certificate provide? So, firstly, it provides identification and authentication. The person or entities with whom we are communicating are really who they say they are. So, that is proved by certificates. So, then we have confidentiality. The information within the message or transaction is kept confidential. It may only be read and understood by the intended sender. Then there's integrity, there's non repudiation. The sender cannot deny sending the message or transaction. The receiver, we'll get to non repudiation and I'll explain how non repudiation comes into digital certificates. So, digital certificates are actually issued by authorities who are business, who make it their business to actually certify people and their organization with digital certificates. Now, you can see these on Google Chrome. Now, let me just open Chrome for you guys, and you can see it out here. You can see certificates, and you can go into the issuer statements, and you can go into all sorts of stuff. So you can see it's issued by Encrypt Authority X3, so that's an issuing authority for digital certificates. Now, that was all about the theory of certificates. Let's go and see how you can create one. So to create a digital certificate, we are going to be using the OpenSSL tool again. So first of all, let me show you how to create a certificate. So we are going to be using the OpenSSL tool for that. So first of all, let me clear the screen out. So in this case, I'm going to generate a certificate authority certificate. So I'm doing an RSA key here to use inside the certificate. So first of all, I need to generate a private key. So to do that, as I had just showed you guys, we can use the OpenSSL tool. You go OpenSSL and gen RSA, and we're going to use DES3. Then we're going to out it, and let's call it ca.key. And we're going to use 4096 bits. So I'm doing an RSA key here to use inside the certificate. So I'm generating a private key, and the private key is used as a part of the certificate. And there's a public key associated with the certificate. So you've got public and private key, and data gets encrypted with the public key and then gets decrypted with the private key. So they are mathematically linked at the public and private key because you need one for the end of the communication and the other for the other end of the communication. And they have to be linked so that the data that gets encrypted with one key gets to be decrypted with other key. So this is asking for a passphrase, and so I'm going to be giving my name as a passphrase. So that has generated the key for us. So now I'm going to generate the certificate itself. So I'm going to be using the OpenSSL utility. So first of all, you say OpenSSL, and you say request. So it'll be a new request, and it's going to be an X509 request. It's going to be valid for 365 days. And let's see, the key is going to be ca.key. And we're going to output it into CA, or let's call it edureka.crt. So this is a certificate that I'm producing in the name of the company that I'm working for. So that is edureka. So it says it's unable to load the private key. Let me just see, is the private key existing? I had a previous private key, so let me just remove that. Does it have a ca.key? Seems like I put the name differently. So let me just try that again. Open SSL. Then we do request. So we're requesting a new certificate, and it's going to be X509, and it's going to be there for 365 days, and key is ca.key. Apparently that's what it's called out here. So, and it's going to be out into edureka.crt. Let's see if that works. So let's enter the passphrase. So it's my name. So now it's going to ask me a bunch of information that's going to be inside the certificate. So let's say it's asking the country name. Again, so let's put in the state. Okay, so IN. State, province name, some state. So Bangalore. Locality, let's say Whitefield. Organization name is Edureka. Unit name, Brain Force. Common name, let's leave that out. Email address, let's leave that out too. And we have our certificate. So if you go and list out your files, you'll see that there is a certificate called edureka.crt out here, which is highlighted. Okay, so now if you want to view this file, you could always use the OpenSSL. You could always use the OpenSSL utility. So you say you want to read an X059 request and you want it in text, and what you want to see is edureka.crt. Okay, so that is the certificate. So you see that it has all the signature, it has signature algorithm, it has all the information about the certificate, and it says signature issuer is CIN in state Bangalore in location Whitefield, Idoreka Brainforce validity. It has all sorts of information. So that was all about digital certificates, how who issues digital certificates, where are they useful. So this is basically non-repudiation. So nobody can say with this certificate that if this certificate is included in some sort of a website and that website tends to be suppose malicious and there's a complaint. Now the website can't go to a court of law and say they didn't know about this because the certificate that was included had their private key and the private key was only supposed to be known to the company. So that is non-repudiation. You just can't deny that you didn't do it. Okay, so that was all about certificates. Now moving on. Okay, so moving on, we are going to be talking about cryptographic hashing. Now, while the word cryptographic is in the term cryptographic hashing, and it does lead you to believe that there is encryption involved, there is no encryption involved in a cryptographic hash. There is a significant difference between hashing and any sort of encryption, and that is primarily that encryption is a two-way process. When I encrypt a piece of data or a file or anything else, what I'm doing is putting it into a state where I expect it to be able to get it back out again. In other words, when I encrypt a file, I expect it to be able to decrypt the file and get the original contents. Hashing is a one-way function on the other hand. Once I've hashed a piece of data or a file, there is no expectation and ability to get the original piece of data back. Hashing generates a fixed length value and different types of hashing will generate different length values. For example, MD5 will generate a different length value than SHA-1, and they're both hashing algorithms, but they generate different length values. And the resulting value from a hash function should be in no relation at all to the original piece of data. As a matter of fact, if two inputs generate the same hash value, it's called a collision. And if you can generate collisions, you may be able to get a point where you can generate a piece of data that are going to generate the same hash values, and that leads you to the potential ability to break the particular hashing algorithm that you're using. So what we can use hash is for, well, one thing we can use hash is for file integrity. We can run a hash on a file and get a value back, and later we can check that the value to make sure if it's the same. If it's the same, I can be sure that the same file was hashed in both instances. So let me just show you an example of what I just said, that if we hash a file, we'll get the same hash every time. So remember the certificate that we just created. Let me just log in again. So we are going to hash this certificate and it will create a certain hash. And we are going to see that every time we hash it, we are getting the same hash. So we can use this command called md5 sum and we can do edureka.crt. So this is the hash produced after you've hashed edureka.crt. So if I do an MD5 again, so MD5 is a hashing algorithm that you should know of. So edureka.crt and it will produce very similar hash. Let's see if SHA-1 works like this. So SHA-1 edureka.crt. Okay, SHA-1 is the SHA from the SHA utils package. Okay, so I've proved my point that with MD5, which is a cryptographic hashing algorithm, we are getting the same hash back. So if you are able to produce the same hash, that means you have broken the algorithm in itself. So if you run MD5 on Linux, you can get a version of MD5 and MD5 summation program on Windows and Mac OS, where with the utility MD5, which does the same thing. So I just showed you the file and I hashed it. And another reason we use hashing is we are storing passwords. So passwords are stored after hashing. We hash the passwords, and the reason for hashing passwords is so you're not storing the password in clear text, which would be easily seen even if you got it protected with permissions. If I hash the password every time I hash that password, I'm going to get the same value back from the same algorithm. So what I do is store the hash in some sort of password database. Since it's a one-way function, you can't get the password back directly from the hash. Now, what you can do with most password cracking programs, do some variation of this, and you just generate hashes against a list of words, and you'll get a hash value that matches the one in the password. Once you get the hash that matches the one in the password, you know what password is there and here, and we come back to the idea of collisions. If I can take two different strings of characters and get the same values back, then it's easier to crack the password because I may not necessarily get the password, but if the hash that I get back from a particular string of data is the same as that I get from the original password, then it doesn't matter whether I know the password because the string of data that I put in is going to generate the same hash value that you're going to compare when you log in. And this hash value will just give you that it's valid and you'll be able to log in. So suppose the password that you chose while making your account is dog, and the dog word produces this hash value. And if I were to like hash cat with the same algorithm, and if the algorithm was prone to collisions, it might produce the same hash value as dog. So with the password cat, I could open up your password. I could open up your account. So that was all about hashing and hashing algorithms. Let's move on now. Okay, so in this part of the video, we're going to go over SSL and TLS. Now, SSL and TLS are ways of doing encryption, and they were developed in order to do encryption between websites, web servers, and clients or browsers. SSL was originally developed by a company called Netscape, and if you don't remember, Netscape eventually spun off their source code and became Mozilla Project, where we get Firefox from. So back in 1995, Netscape released a version 2 of SSL, and there was a version 1, but nothing was ever done with it. So we got to version 2 of SSL, and that was used for encryption of web transmission between the server and the browser to do a whole number of flaws between the server and the browser. Now, SSL version 2 had a whole number of flaws, and SSL 2 has the type of flaws that can lead to decryption of messages without actually having the correct keys and not being the right endpoints. And so Netscape released SSL version 3 in 1996. And so we get SSL 3.0, which is better than 2.0, but it still had some issues. And so in 1999, we ended up with TLS. Now, SSL is secure socket layer and TLS is transport layer security. They both accomplish the same sort of thing, and they're designed for primarily doing encryption between web server and web browsers because we want to be able to encrypt the type of traffic. So let me show you what kind of traffic looks like. So first of all, let me open Wireshark. And out here, I already have a TLS scan ready for you guys that you can see. We have all sorts of TLS data. So you can see that here's my source and it's 1.32 and destination is 7612.4059.46, doing a client key exchange and the change cipher spec and an encrypted handshake message. And then we start getting application data. So there are some other steps involved here, and you're not seeing all of it with this particular Wireshark capture because, again, we get fragmented packets, and at some point it starts getting encrypted. And you can't see it anyways because Wireshark, without having the key, can't decrypt those messages. But what ends up happening is the client sends a hello, and the server responds with a hello, and they end up exchanging information as a part of that. Now, including version numbers supported, and you get random number, and the client's going to send out a number of cipher suits that may want to support an order, and it can support the server, and it's going to pick from those suite of ciphers. Now, then we start doing the key exchange and then do the change cipher spec and from the client and server, and eventually the server just sends a finished message. And at the point we've got this encrypted communication going on, but there's this handshake that goes on between the two systems. And there's a number of different types of handshakes depending on the type of endpoints that you've got. But that's the type of communication that goes on between servers and the client one. Important thing about using SSL and TLS is, as I mentioned, some of the earlier versions had vulnerabilities in them, and you want to make sure that the servers aren't actually running those. So you want to run some scans to figure out the type of calls and ciphers that different systems use. So for this, we can use something called SSL scan. So this is available for Unix. I'm not really sure if there is something that is similar for Windows or Mac, but on a Unix-based system that is Linux, we can use SSL scan. So let me just show you how to use that. Clear this part out. So what we can do is run SSL scan again, suppose www.edureka.co. So I'm going to do an SSL scan here against the website, and you can see it's going out and probing all the different types of ciphers that we know on this system. Start with SSL v3 and are going to TLS version 1. And we could force SSL scan to try to do an SSL v2 if I scroll back up. Here I get the surface ciphers, which is SSL version 3. It's using RSA, and it's using RSA for the asymmetric. Now, in order to do the key exchange, and once we get the session key up, we're going to use AES 256, and then we're going to use the secure hash algorithm to do the message authentication, or the MAC. It sometimes calls the HMAC for the hashed message authentication code. And what it does is simply hashes the MAC address that you would check one side against the other to make sure that the message hasn't been fiddled with in transmission. You can see here all the different types of cipher suits that are available. Here's TLS running RC4 at 40 bits using MD5, so that would be a pretty vulnerable type of communication to use. And between the server and the client, a 40-bit cipher using RC4 is a low-strength cipher, and we would definitely recommend that clients remove those from the supported ciphers that they have on their server. All that configuration would be done at the web server as well as when you generated your key and your certificates. Normally, certificates would be handled by a certificate authority. Now you can also self-sign certificates and have those installed in your web server in order to do communications with your clients. That the challenge with that is browsers today warn when they see a certificate against a certificate authority that is entrusted of it, and it doesn't have any certificate authority at all. So you'll get a warning in your browser indicating there may be a problem with your certificate if your clients are savvy enough. And if the users are savvy enough, you may be able to make use of these self-signed certificates and save yourself some money. But generally, it's not recommended simply because clients are starting to get these bad certificates. And when they run across one that's really a problem, a real rogue certificate, they're going to ignore the certificate message in their browser and just go to these sites that could have malicious purposes in mind and may end up compromising the clients or your customers or users. So that's SSL and TLS and how they work and negotiate between servers and endpoints. Okay, so now that we've talked about TLS and SSL, let's talk about disk encryption. Now, disk encryption is actually something that was not really difficult to do, but sort of out of the reach of normal desktop computers for a really long time. Although there have long been ways to do encryption of files, and to a lesser degree, maybe entire disks, as we get faster processors, certainly encrypting the entire disks and being able to encrypt and decrypt on the fly without affecting performance is something that certainly comes within reach. And it's a feature that shows up in most modern operating systems to one degree or another. Now, these days, we're going to look at a couple of ways here of doing disk encryption. I'm going to tell you about one of them first, and it's not the one I can show. I can't really show the other one either. So with Microsoft, their Windows system have this program called BitLocker. Now, BitLocker requires either Windows Ultimate or Windows Enterprise. I don't happen to have either version, so I can't really show it to you, but I can tell you that BitLocker has ability to do entire disk encryption and they use AES for the encryption cipher. And the thing about BitLocker is that they use a feature that comes with most modern systems, particularly laptops. They'll have this chip in them that's called the Trusted Platform Module or TPM. The TPM chip is what it does is it stores the keys that allows the operating system to be able to access the disk through this encryption and decryption process. And they use a pretty strong encryption cipher, which is AES, but you have to have one of the couple of different versions of Windows in order to be able to use BitLocker. And it's one of those things you would normally run in an enterprise, and so that's why they included it on its enterprise version. Now, on the macOS side, they have this thing called File Vault, and you'll see in the system preferences on the security and privacy, if you go to File Vault, you can turn on File Vault. Now, if you have the little button that there says turn on file vault, then you can turn on the file vault and it would ask you about setting up keys, and it works similar to Windows BitLocker. Now, PGP happens to have the ability to do disk encryption, and you can see that in the case of this, you've burned the system. They've got a package called GDE Crypt, which is a GUI that allows you to map and mount a created encrypted volume. So I could run GDE Crypt, and it would help me set up the process of encrypting the volumes that I've got on my system. Now, disk encryption is a really good idea because when you are working with clients, the data is normally very sensitive. So, as I mentioned, you can always use things like BitLocker and Windows Vault or other such softwares for disk encryption. So, what I mentioned before is now not only possible, it's very much a reality with current operating systems. Now, let's talk about scanning. Now, scanning refers to the use of computer networks to gather information regarding computer systems. And network scanning is mainly used for security assessment, system maintenance, and also for performing attacks by hackers. Now, the purpose of network scanning is as follows. It allows you to recognize available UDP and TCP network services running on a targeted host. It allows you to recognize filtering systems between the users and the targeted hosts. It allows you to determine the operating systems in use by assessing the IP responses. Then it also allows you to evaluate the target host TCP sequence numbers and predictability to determine the sequence prediction attacks and the TCP spoofing. Now, network scanning consists of network port scanning as well as vulnerability scanning. Network port scanning refers to the method of sending data packets via the network to a computer system specified service port. This is to identify the available network services on that particular system. This procedure is effective for troubleshooting systems issues or for tightening the system security. Vulnerability scanning is a method used to discover known vulnerabilities of computing systems available on a network. It helps to detect a specific weak spot in an application software or the operating system, which could be used to crash the system or compromise it for undesired purposes. Now, network port scanning as well as vulnerability scanning is an information gathering technique, but when carried out by anonymous individuals, they are viewed as a prelude to an attack. Network scanning processes like port scans and ping swipes and return details about which IP address map to active live hosts and the type of service they provide. Another network scanning method known as inverse mapping gathers details about IP addresses that do not map to live hosts, which helps an attacker to focus on feasible addresses. Network scanning is one of the three important methods used by an attacker to gather information during the footprint stage, and the attacker makes a profile of the target organization. This includes data such as organization's domain name systems and email servers, in addition to its IP address range. And during the scanning stage, the attacker discovers details about the specified IP addresses that could be accessed online, their system architecture, their operating systems and services running on every computer. Now, during the enumeration stage, the attacker collects data, including routing tables, network user, and group names, simple network management protocol data, and so on. So now let's talk about intrusion detection evasion. So before we get into IDS evasion, let's talk about what exactly is an IDS. Now, an intrusion detection system, or IDS, is a system that monitors network traffic for suspicious activity and issues alerts when such activity is discovered. While anomaly detection and reporting is primary function, some intrusion detection systems are capable of taking actions when malicious activity or anomalous traffic is detected, including blocking traffic sent from suspicious IP addresses. Although intrusion detection systems monitor network for potentially malicious activity, they are also prone to false alarms or false positives. Consequently, organizations need to fine-tune their IDS product when they first install them. That means properly configuring their intrusion detection system to recognize what normal traffic on their network looks like compared to potentially malicious activity. An intrusion prevention system also monitors network packets for potentially damaging network traffic, but where an intrusion detection system responds to potentially malicious traffic by logging the traffic and issuing warning notification, intrusion prevention systems respond to such traffic by rejecting the potentially malicious packets. So there are different types of intrusion detection systems. So intrusion detection systems come in different flavors and detect suspicious activities using different methods. So kind of intrusion detection is a network intrusion detection system. So that is NIDS is deployed at a strategic point or points within the network where it can monitor inbound and outbound traffic to and from all the devices on the network. Then there is host intrusion detection system, that is HIDS, which runs on all computers or devices in the network with direct access to both the internet and the enterprise internal network. HIDS have an advantage over NIDS in that they may be able to detect anomalous network packets that originate from inside the organizations or malicious traffic that NIDS has failed to detect. HIDS may also be able to identify malicious traffic that originates from the host itself, as when the host has been infected with malware and is attempting to spread to other systems. Signature-based intrusion detection system monitors all packets traversing the network and compares them against a database of signatures or attributes of known malicious threats, much like antivirus softwares. So now let's talk about into IDS evasion. Okay, so now let's talk about IDS evasion. Now, IDS is an intrusion detection system, as we just spoke about, and is there to detect exactly the types of activities that we are engaged in sometimes. And sometimes you may be called in to work on a target where activities are known and should be known by the operators or the operations people involved in monitoring and managing the network. And the idea being not only do they want to assess the technical controls that are in place, but they also want to assess the operational procedures and ensure that the systems and processes are working the way that they are supposed to be working. Now, when you are engaged with a target that you are in full cooperation with, you don't need to do these types of evasion tactics. All these techniques may be actually avoided. But if you're asked to perform an assessment or a penetration on a target where they are not supposed to see your activities, then you need to know some different techniques to evade detection from an IDS. So we're going to talk about a couple of different things that you can do. So one thing that you can do is manipulate packets to look a particular way. Now, for this, there's a tool called Packeth. So Packeth is a really good way to actually manipulate traffic, and by actually manipulating the contents of a packet, like you can specify the destination and source. So it's a really useful tool to set up packets, look a particular way. One thing it can do is allow you to spoof IP addresses. So I could set a source IP address here that was something completely different from mine. Now, if I'm using TCP or UDP, I'm not going to see the response back. And in this case, TCP, I'm not even going to get the three-way connection made because the responses are going to go back to the source IP. But what you can do is, in addition to spoofing, you can set up particular ways that a packet may look, like changing the type of service or by changing the fragmentation offset or by different flag settings that may allow you through an IDS without maybe getting flagged. And it may also allow you through a firewall. Now, it's a slim possibility, but it's a possibility. Now, another thing you can do is use Packeth to generate a lot of really bogus data. And what you might do is hide in the noise generated by Packeth. So you could create some really bogus packets that are sure to set off IDS alarms, and then you can run some legitimate scans underneath and hopefully be able to get some responses. Different from mine. Now, if I'm using TCP or UDP, I'm not going to see the response back. And in this case, TCP, I'm not even going to get the three-way connection made because the responses are going to go back to the source IP. But what you can do is, in addition to spoofing, you can set up particular ways that a packet may look, like changing the type of service, or by changing the fragmentation offset, or by different flag settings that may allow you through an IDS without maybe getting flagged. And it may also allow you through a firewall. Now, it's a slim possibility, but it's a possibility. Now, another thing you can do is use Packet to generate a lot of really bogus data. And what you might do is hide in the noise generated by Packet. So you could create some really bogus packets that are sure to set off IDS alarms, and then you can run some legitimate scans underneath and hopefully be able to get some response.